PySpark is the backbone of data engineering interviews, but in 2025, level is really up. Instead of asking about those simple PySpark transformation functions, interviewers are actually asking about real-time scenarios and not the simple ones. The complex ones including handling upserts with the backdated refresh, implementation of slowly changing dimension type 2 using PySpark, building Python classes for reusability of code and object-oriented approach, incremental data ingestion of files using Spark structured streaming, handling and flattening JSON data that we can receive from sources like Kafka, building delta live tables in PySpark notebooks. This might sound challenging to master these areas, but don't worry. I will help you master all these areas using step-by-step guide even if you are a beginner. And you know what? I can guarantee that you will outstand in the crowd if you complete this video. And yes, I just need your love and support on this channel, and you can just show that in the comment section right now. And now, let's get started with this masterpiece. Fam, happy Sunday and happy holiday season. I hope you are enjoying your quality time with your family, with your friends, with your all the loved ones, whatever. So yes, you should enjoy, but at least spend 10% of the time in upskilling yourself, because world is changing at a very fast rate. Okay, and you need to just be ready for that. Yes, enjoy holidays, enjoy your quality time, but at least 10% of the time you can just spend on yourself, right? So that's it. So that is why today I have just come up with amazing video that will add a lot of value in your career, I would say, or in your personal growth as well. It is called PySpark real-time scenarios. The thing is, the dynamics of the data engineering world, especially big data, is totally changed. Earlier, PySpark real-time scenarios mean, hey, how you can just transform this column. Hey, how you can just do this. Hey, how you can just perform group by. These were like real-time scenarios in PySpark, and that is the reality. Because at that time, competition was really not much, and PySpark was like a kind of niche. But right now, PySpark is just like, you can say Python for data engineers. You have to use PySpark almost everywhere. So in the today's world, PySpark real-time scenarios mean, like, obviously you would have just watched the introduction part, and where you can see like so many real-time scenarios, slowly changing dimension type 2, upserts, JSON handling, and so many things, right? So how you can just master those things even if you are a beginner? Don't worry, I will help you to master all these areas. And yes, we're gonna talk about so many amazing and some complex as well, because you need to level up your skills, right? So we're gonna just talk about complex real-time scenarios, which are, you can say, the hottest topics in the world of PySpark. Okay, and it is directly related to your interviews, and it is directly related to your day-to-day activities that you are performing in the corporate world. So the thing is, let me just be honest with you. If you are working in a consultancy firm or basically a service-based company, right? You know the reality how they hire the people. They simply pick the people, okay, and they simply put the people on the projects. And then the individual will be suffering a lot. Why? Because they hired it, like they hired him or her, okay, they hired them. Then they just simply put those people on the projects. Even if they do not have any kind of knowledge, they will simply put it, because that's the business, right? That's how their companies are growing, right? So now if you are one of those people, and it's not your fault, it's just like the politics that those companies, services companies, actually play. So now you will be struggling a lot because you are not prepared for those scenarios. Service-based company put you on the project for any product-based company, and product-based companies' expectations are to perform all those things, right? Because they are just paying the service-based company. But what is your fault? That there's no fault, okay? Especially from your end. You just need to upskill yourself, and don't worry, you have Ansh Lamba now. So I'll just help you a lot, and I would say this video will help you a lot to upskill yourself. If you are already on the project, or if you will be on the project, or if you're just trying to crack some interviews, this video is like one-stop solution for all the areas. Because once you are landed as a, you can say, data engineer, you need to perform all those things, right? Then only you can just sustain your title. Then only you can sustain your job. cracking the interview is just like one part of the journey, just one part. You need to sustain yourself, right? So that is why this video is for you, and this video will help you a lot. And you already know like what we're gonna cover in this video, and all the scenarios are important, I would say very important. So just take out your notebook, okay, just take out your laptop and let's get started. Now let's talk about our first scenario, and I would say this is a kind of scenario which is non-negotiable, and you will know the reason why. So let me just read out the scenario for you first of all. So the scenario says a retail company receives daily updates for its products catalog, including new products, price changes, and discontinued items. And that is the scenario that will be there for you if you are working in the real world, because every company is like obviously selling some services, products, and everything. They can get changed, right? Okay, so now instead of overwriting the entire data catalog or basically catalog or simply appending new records, they need to upsert the incoming data, updating existing products with the latest information and inserting new products, ensuring the catalog remains accurate and up to date in real time. So basically the thing is, first of all, you need to catch the word called upsert. Whenever you see this word upsert in your scenarios, you should get that hint, hey, I want to apply a logic where I need to handle the upserts. Now if you are not sure about what are upserts, basically they are, you can say, merge statements which help you to just either update the data if the data is there, or simply insert the data if data is not there. So how you can just handle that scenario? You will say, hey, we already know, we have applied like upsert so many times. So let me just tell you one tip as well in this scenario, which can be asked in your interviews as well. Okay, along with this scenario, obviously this scenario will be there for sure, but that particular tip can help you to just tackle the, you can say, questions that can be asked along with this question. Okay, before that, Ansh Lamba, where is the data set? Where is the platform? Where is the setup? Where is the setup? So good thing, we gonna use hosted platform, okay, that is Databricks. If we are just talking about PySpark, what is the best platform to practice? Obviously Databricks. Why? We do not need to manage clusters, we do not need to manage anything, we just need to practice PySpark, that's it. Okay, so we will be using Databricks free edition. That means you do not need any kind of cloud setup as well. Simply log in and just get started. If you already have a Databricks free edition, which I feel that you already have, then it is good. If you do not have, don't worry, let me just show you how you can just set up your free account. It will hardly take, I think, just 1 minute. It is very simple. Let me just show you. So in order to just create Databricks free edition, you simply need to go to your browser and simply search, let's say, Databricks free edition, and you will be landing on this particular search bar, and you can actually select any link. Let's say I'm selecting this one, try Databricks for free, and you will land on this particular page. Okay, so here you do not need to click on this express setup. Why? Because we are not using express setup. Express setup is also one of the free editions that we have, but just for the limited time, that's it. But this is the thing that we are looking for, which is this one, Databricks free edition. So simply click here and you will be able to just create your free Databricks account. Okay, let me just click here, and here you simply need to provide your email account, either Gmail or Microsoft account. If you have provided that, then what you will do, you will again land on this page, and this time instead of clicking on click here, you will click on login. Why? Because this time you already have the account, you simply need to log into your account. Okay, so if I click here, I will see this page. Okay, and this time you need to provide the same email account that you have just used while creating the Databricks edition, and that's it. That's it. It is that simple. So I already have that account and I have pinned that link here. So I will simply click here and let me just log in and let me just show you how does it look like, and let's get started with the data. Okay, so this is the home page that you will also see when you create your Databricks account, and this is the home page. And obviously we are not going to discuss Databricks in detail. We are just focusing on the PySpark real-time scenarios. We are just using Databricks as a platform so that we can write and run our PySpark code. That's it. We are only and only focusing on PySpark real-time scenarios because PySpark is PySpark. It can be used with your Databricks. It can be used with your self-hosted clusters as well. If some big companies have their own IDEs, if they have their own applications built on top of open source PySpark, then also you will be able to understand what's going on. So we are just simply using platform, Databricks as a platform. That's it. You can either run PySpark code in your local, you can say cluster as well. That's not a big deal. So that's up to you how you want to just run your code. Okay, makes sense. Okay, very good. So now, first thing first, one thing that I will just recommend, once you log in with your Gmail account or any account, simply click on this button, and here you will see, maybe you will be seeing a button called previews. Sometimes you will not be able to see, sometimes you will see. It gets changed as per the, you can say, updates. So if you are seeing previews button, make sure you have enabled all the previews. What will be the benefit of it? You can just use the, you can say, modern UI and all. Okay, that's not like recommended, but yeah, you can just do that. Once you enable all the things, simply go to settings and then developer, and then these are all the toggles that I have either turned on or off. So you can just copy the same thing. That's why I'm scrolling down slowly, so that if I'm using a different UI and you are not having that UI, you'll be saying, hey, from where I can just get this UI. So it is very simple. You can simply copy and paste it. These two are very important. So just make sure these are turned on, and sometimes they will only be available if you have turned on the previews, if they are visible. Okay. Okay, makes sense. Let's get started. So first of all, what we need to do, you simply need to go to workspace. Okay, because workspace is the area where you just create your folders and all the things. I have already created so many folders because I was using this particular account for creating other videos as well, like for Databricks. So let me just clean the resources, and that's it. So if you have not seen those videos, I will recommend you to watch those videos, because what are you doing, man? Databricks is like making so many crazy changes. You should know all of these things. So let me just delete this as well, move to trash, because I have just recently launched Databricks interview question series, and that is like purely based on the latest Databricks questions and Databricks updates, because in June, July 2025, they have made like crazy changes. So you can just go and check it out. It's like amazing video. And Databricks interview. Okay, move to trash, move to trash. In your case, you will not be seeing these folders, so do not worry at all. And yes, in the previous video, we talked about Git as well and so many amazing things. So let me clean the resources. Usually I just publish all these things to GitHub. So if you just want these resources, they will be available on GitHub. So don't worry. So let's create our new folder. So I'll simply create a normal folder. You can either create Git folder as well. But obviously if I create Git folder, then it will become a Databricks video, right? Because we are not focusing on these things. So I'll simply create a normal folder, and I'll simply say PySpark scenarios. Okay, let's create it. And this is our folder. So within this, I will create a simple notebook. That's it. So let me just collapse this area. So this is basically the UI that you should be familiar with if you are working in the big data world, because we work with notebooks a lot. And we rarely use like normal Python files, but with the advancement and DLT, declarative frameworks, we are switching back to those Python files. Do not worry, we'll talk about delta live tables as well in this particular video series, which is real-time scenarios, because there's a fun fact I will tell you later in the video. Okay, amazing fun fact, and I also got to know recently. So it's like changing the dynamics of PySpark. So first of all, let me just turn on the cluster, because obviously we need a compute to run our code. So it is now being turned on, and it will take hardly few seconds, because this is a serverless compute which is not managed by us. Databricks is managing this particular compute. Okay, simple. So now we are all set to run our pieces. Okay, so first of all, what we need to do, we are talking about, hey, we want to just take care of the changes that we have in the products table and blah blah blah, so many things, right? So at least we should have a catalog to work with, right? So simply click on this catalog button, and you will see this tab. So let's create a catalog, or you can just click on these three toggle buttons. Click on catalog, and let's create a new catalog. So click on plus, then create a catalog, and here you can just provide a name. I will simply say PySpark Kata. Okay, standard, and simply click on create and configure catalog. Yeah, let's configure it, and then let's say next, then save. That's it. Configuration is done. So this is like your PySpark Kata. Okay, so in this particular catalog, we'll be creating our schemas and all those things. So let's create a schema called source. Okay, so this is my source schema. and perfect. So this is empty, obviously. Now I want to create a table within this source schema, and this will be called as basically a products table because we are just dealing with the products data, right? So let's do that. Basically, I will simply go to SQL editor. Okay, and let me just collapse all the unnecessary queries that I have opened. So basically this SQL editor will open the a kind of SQL workbench for me, not SQL workbench, but yeah, a similar thing. Okay, so it is saying all these queries are here. So let me just click on this plus tab, basically SQL query. So this is the area where we can just type our SQL code. So it is the area where you can just write your Spark SQL code as well, but we are not covering this as well. So we are simply creating our source. So I can simply create a quick table. I will simply say create table, and for that I first need to choose this particular, you can say, workspace, which is PySpark Keta, and I want to create it in the source schema. Sometimes these two buttons will not be active, so if you want to make them active, you want to select this new SQL editor on. In your case it can be turned off. So if I just turn it off, some UI will be changed, see. And if I just turn it on again, where is that button to turn it on? Where is that button now to turn it on? Let me just see. So if I just scroll down, yeah, here it is, turn on. Obviously new UI is better, so I will simply switch to the new UI. So I will simply say create table, table name, and this, you need to turn this on as well. This is a different compute. This is not same compute that you are using for the notebook. So this is totally a different compute. And how you can just turn it on, simply click on SQL warehouses, that's it. And here you will see this compute, just turn it on by clicking on this button, that's it. Make sense? Very good. So now let's create this query. I will simply say create table and pick this PySpark Keta and source. So table says products. Oh man. Create table products, and I will simply create ID of integer type, name, price. Okay, not decimal. I will simply pick, let's say, integer, and then I will say category. That's it. So these are the 4 columns that I want to keep. And one more important question, which not question, like column, which is very, very important, which is called updated date. Okay, updated date will be of timestamp. Make sense? Okay, so let's create this, and I will also insert some data. Insert into products, and then values. So now let's pick one, and let's say name can be anything. And why AI is not suggesting me the values? Why? Edit code with assistant, it is turned on. It is lazy. Sometimes it is lazy. So I will simply say 1, and then yeah, this is good. And current timestamp, perfect. Then MacBook 2000, and t-shirt 50, clothing timestamp, perfect. T-shirt 100, clothing, and that's it. I would say let's add one more. Okay, so this is basically a store. Okay, so we are inserting these values in our products table. Make sense? Okay, start, attach, and run. So let's attach this. So this is basically our source that we have created. Okay, so this is now executing the query, and these are the 5 records. So this is our source table, right? So now you want to create your destination table by handling all the changes as well. And you know what? You need to perform this using initial load and incremental load both in the same notebook. Don't worry, I will just tell you that as well. That's why this video is for you, bro. Just for your learning, just for your growth. And this table is created. So let me just go back to my notebook. You can go back to this notebook from here as well. I will simply select workspace and PySpark scenarios. Perfect. So this is my notebook. So let me first of all rename it. I will simply say scenario 1. And don't worry, I will just provide this notebook to my GitHub repo. You can simply download it. Okay, and just for your reference, I would recommend you to just write your own code. Okay, but this is just for the reference. If you are stuck, if you are facing any error, then only you should refer this. Okay, very good. And I hope you are taking notes. I hope. So let's say I want to say source, querying source. Okay, so this is basically a markdown cell that we create. So this is querying source. Let me just make it bold. Okay, perfect. So these are Databricks things. You do not need to worry at all for this. Okay. Okay, querying source. So that is perfect. So now we are just trying to query the source. I will simply say select asterisk from what is the Databricks data catalog name. It is, I think, PySpark data. Yes, dot source dot products. Let's query this and we will be able to see the data here. So if you just want to change the theme of this, you can by just clicking it here, or I think it should be doable from here. Not really. Earlier it was available when we didn't have this thing, tabs and all. I think you can from here. If you just want to do it from here, you can just go to settings and just go to the developer. Then from light mode, you can just pick dark mode if you like this dark mode, and if not, you can simply pick the same thing. Okay, so this is our notebook right now. Okay, perfect. So in your case, this text color can be different because I have picked a specific dark theme. It is called, I think, I don't remember the name. So you can just try and test it if you like this color. Okay, so this is my data. As you can see, this is my table. So I want to now query this data, but in this order, in such a manner that I will be handling upserts. So how I can just do that? First of all, I will simply create a text cell. I will make it H2 bold, and I will simply say upsert, or basically upserts. Okay, so now what I need to do, I will simply say if. What does if mean? Let's ignore if for now. Let's say how we can just apply upsert. So basically we need to pull this data. Okay, this data, we need to pull this data and we need to store this data in a destination. Make sense? So now where is our destination? Make sense? We need to just first of all create the destination. Like, where is our destination? Where is our sync folder? And I would recommend to ask these questions while answering if these are being asked in the interviews. Make sense? So it is very easy. In Databricks, you can create something called as volume. And how you can just do that, I will simply create a schema. Let's say source. Let's create within that one as well. Not a big deal. So if you click on this, and this is basically the table that you have created. If you want to create a volume, you can either create from here as well, or you can just go here to catalog and select your catalog and then select your schema, then click on create. And then we'll be creating a volume. Now, what is a volume? This is indirectly related to your PySpark, because whenever you are working with PySpark, you will hear a word called volume if they are using Databricks. If they are using something else, let's say a cloud storage, you will be hearing data lake or anything else. So basically volume is the destination where you can just hold any kind of data. It is a kind of cloud location, but a managed cloud location. That means you can govern this using Unity catalog. Make sense? I will simply say volume name as, let's say, DB volume. Perfect. So this is my DB volume. And this is a managed volume, obviously, because we are not using any kind of cloud account. So this is done. It is that easy. Now I can simply say, hey, I want to go to my notebook. And this is my recent tab. And I will simply say, go to scenario 1. Perfect. So now the scenario is, you already know the scenario, but we have some iterations in that, right? So far, we have reached to the destination step. So now the situation is we want to store this data in this particular volume. Make sense? In this volume. In this volume, you can create X number of, you can say, folders. So let's say I want to create a directory. I can simply say, hey, create a directory called products sync. Let's say I want to save my data in this particular directory. And if you click on this one, you will see product sync is there for you. Make sense? You can also use DB utils to create these things, but it is fine. Okay, by using mkdirs and all those things. So now you will say, hey, I want to create my delta, basically data in this particular location. So what is the format for that? So there are some steps. First of all, you need to create a delta object. Okay, so let me just add comments for you. Creating delta object. And how you can just create that? For that you would need to import delta.tables from delta.tables, I guess. Yep, from delta.tables import delta table. Make sense? Okay. So once you import that, then you will create a delta object on top of the sync location. I will simply say DLT object equals delta table dot for path, not for name, because we do not have any kind of table for that. And I will define my Spark variable, which is Spark. And then I need to provide the location. Now, what is the location of this volume? You do not need to worry about the location. By the way, there's a specific syntax for it, but for the easy, you can say setup, click on these two arrows and that's it. You will be having your URL ready in front of you. So now once if it is ready, okay, once this object is ready, then we need to apply the merge condition. Okay, how we can just do that? There's a syntax, there's a proper documentation that I will just show you, don't worry, so that you can just take notes. DLT object, okay, dot alias. First of all, alias, because every time we just perform upsert, we just go with the alias for better code understanding, and if anyone else is reading the code, the guy will be or the girl will be able to understand it. Okay, I will simply say this is my destination, so I will simply say target. Okay, so this is my object. I want to apply merge with this particular table. And now what is the source? Okay, now what is the source? That is a good question. This is a target. Okay, now where is the source? So let me just tell you where is the source. So let me just remove this line, and we first need to create a data frame on top of it. There are multiple ways you can do that. So what I will do, I will simply say code, okay, and I will simply say df equals spark.read.format, and then I will simply say delta, and then I will simply say dot load, and then I can just provide the location as well. But in this case, we already have a table, so we do not need to worry about anything. We will simply say dot read dot table. That's it. And just provide the table name, which is PySpark kata dot source dot product or products. Product or products. Okay, so this is the table that we are reading. Okay, by the way, we should not read it like this. Really? Yes, we should not read it like this. Like, we can also read it like this. That is like one of the forms that we can read, but usually when you are building real-time projects, you will always be reading like this: spark.sql, and then select asterisk from whatever your table is. Let's say PySpark kata dot source dot products. Make sense? PySpark kata dot source dot product. So this way you can just read your data. Okay, makes sense? Very good. So now the thing is, why I chose this method. There's a reason behind it, because in this way you can apply incremental loading efficiently, because you do not want to read all the data every time, because if you will be reading all the data every time, you would need to add some, you can say, deduplication step as well. And I want to show you that as well, because I want you to become a pro. Okay, so whenever you are just reading the data, you need to make sure that you are performing deduplication as well. What do I mean? So let me just show you the first iteration and you will get some knowledge, and then I will just show you how you build the merge condition. Because see, Upsert is very simple if you just want to learn it from the, you can say, study point of view. But when you're just performing upserts in the real world, that is why this video is for you, real world scenarios. You need to add so many other things along with upsert. Okay, so that gap will be filled by this video, and I know it is being filled by this video. So let's say you want to create this data frame, okay, and you can even Spark, I think it is fine, spark.sql. Okay, let's say display df. So this is my data. Okay, so very good. So now what we need to do, this is my source, see, df. So I will write here df.alias as source. Okay, I want to merge it with df, or sorry, not df, dlt object, the above one, dlt object dot alias, and alias will be trg, that means target. Now what will be the condition? What will be the join condition? What will be the condition like on which it will be just deciding, hey, I want to update or I want to upsert? It will be the primary key. And what is the primary key? It is id. Okay, I'll simply say source.id equals target.id. Make sense? So this is my merge condition. So if it is done, then I want to say, let me just close it above. Yep. Now once it is done, I will simply say backslash to just go to the next line. Okay, I will say dot when matched. If it is matching, I want to update all the information. Here you need to wait and you need to learn one thing. Just tell me one thing. When you will be just updating all the information, okay, what's wrong with that? Nothing is wrong. Nothing is wrong. It will work fine till the time you are reading new data every time. Let me just give you an example. So let's say this is the data, okay, and the ID2 equals MacBook. Okay, very good. Now the price is 2000. Makes sense. After let's say 6 months, the price is let's say 1500. Makes sense. 1500. Okay, so you want to pick the latest price, right? Okay, but it will work fine because it will simply get the data. Let's say you are running this pipeline after 6 months, it will simply get the data, which will be saying 1500, and it will update the data. Makes sense. But what if you are performing backdated refresh? Now, what are backdated refresh? If you do not know about that, or the one popular term is backfill, if you will be doing that, this will not work. Why? Let me just tell you. Let's say you change the price to 1500. Okay, this is fine. Next day, due to some reason, your business manager said that, hey, I am just missing some data. So I think like pipeline failed in the past month. So can we just backfill the data, or there's any requirement? You will say, yeah, we can just do that. If you will be backfilling the data, your MacBook price will again change to 2000. And that you do not want. You want to compare if it is a latest value or not. That's where the role of condition comes here. So I will simply say condition. Okay, and I can simply say, what is the condition? Condition is target, not target, basically source dot update date should always be either greater than or equals to target dot update date. So what it will do, it will every time compare these two dates. So let's say I am performing backdated refresh. How it will work fine now, because it will simply say, hey, this updated date is smaller than the current date, which is the target.updated date, which is already there in the data. It will simply say, hey, I will not update it. Okay, so it will only update the data if this condition is also matching. So there are basically two conditions now. One is this one, source.id equals target.id. Second condition is this one. Make sense? So this is a real world scenario. And I'll simply say when not matched, insert all. That means simply insert all the records and then dot execute. Make sense? Okay. So now we cannot run this code in one go. Why? So basically we can, but we should not, because this can fail if the target data is not there. What do I mean? So if you know, do we have any kind of data sitting in the destination so that it can compare it with? The answer is no. So I will simply add a, you can say guardrail. Okay, a kind of, you can say validation step. I will simply say if spark dot catalog, okay, dot table exists. Okay, if it exists, and I can just simply provide the name if it is there. Okay, and it will simply do that task. But here we are not actually creating a table. If you see, we are simply updating the, or you can say writing the data to this data lake, or basically volume. So because every time we will not be having, you can say location. Make sense? Now this thing can also be replaced with, let's say, using dbutils. Let's say I want to simply use this thing, dbutils.fs.ls, and I can simply provide that particular data lake location. Okay, maybe this one, maybe this location. So I will simply say dbutils.fs.ls, and if we have any kind of data sitting here which is saying this thing, which is this one, product sync, let's say. So this one and this one, product sync. If dbutils.fs.ls, if we have anything inside it, then we want to, let's say, run this code. Okay, it can just work like this as well. Or let's say I have a folder called data within this. Okay, then it can also work. But the thing is, these all these things, like let's say dbutils.fs.ls, and all these things can work. It's not a big deal. If you want to get rid of all these things, you can simply use try catch method that we do in the programming world. Simply say try. If it fails, you simply need to say accept. And what you need to do in the accept mode, you will be creating a table. Basically, you will be writing this data, right? You will simply say df.write.format, and format will be delta. And you can simply say dot mode is overwrite. Okay, and then you can say dot save, simple. Yeah, so this way you will be performing your initial load as well. See, you will be performing your initial load as well, and you will be performing your incremental load as well within the same code cell. And that's how you do in the real world as well. Makes sense? Try except method, basically try catch method. In Python we call it as like try except. So this is the way you need to perform these things. Make sense? Okay, so let me just run this code and let's see what happens. So it should just write the data in first go, because this command will be running using accept method. But next time this command will be running, this one, try command. And I can even say print just to show you. This is upserting now. Okay, so let's run this and I should see that print command. This is upserting now. And why I'm not seeing? So there's a small typo. We just need to reverse this. So what we are doing, we simply need to say DLT object, and then we need to simply say target, because we apply merge with the destination. Like this is a destination, we want to merge it with source, not source with target. Just think about it. You need to merge your target data with the source, right? You cannot merge your source data with the target. You cannot do the reverse. So yeah, this happens like small silly mistakes. You can simply say df and df.alias. This is source. Perfect. I think it should work now. Okay. I think, yeah, now it is working. Okay, now it is saying this is upserting now. Very, very good. So now it has upserted the data. So that means it is now upserting the data. Now if I just query the data, which is the end table, I will simply say select asterisk from delta, then backticks, delta dot backticks. Basically, this is like backticks, not single quotes. Backtick is available like the button just above the tab button. Okay, I will simply say this is the location, which is this one, db volume and sync. Perfect. So if I just query this, I should only see 5 records instead of 5, 10, 15, anything, because these are the records. Now what is the advantage of it? Let's say I am rerunning this command. So what will happen? It will only and only update the records instead of writing it. Why? Because let me just give you the proof. Because we are only using this ID column. See, we just have 5 records. It has not appended the records. That's how you perform upsert. That's how you perform upsert. Now just a tip. Okay, in this scenario, I just want to stretch it a little bit because this tip will actually help you a lot. Let's say you are adding more data here. Okay, let's say you are updating a record or anything. Let's say you are updating this record. So obviously you will insert this data. Let's say 5, one more, and the name is changed from pants to, let's say, anything. Let's say trouser. Let's say you want to rename it. Okay. So in that particular scenario, okay, you will be having 2 records with the same ID. In that use case, now it's your responsibility being a data engineer to deduplicate your data based on the latest update date. Make sense? Make sense? So let's say I am adding this data. Let's say I want to insert it, and in order to insert it, I can simply go to, let's say, SQL editor, and let's insert some data. Okay. I can also use that notebook as well, but that is fine. So let's say I want to insert this one record only, and I want to rename it as trouser. I know both are different, but let's say, okay. So let me just select this and run. Select attach and run. By the way, this compute will be terminated automatically after 10 minutes if it is not active. Okay, so that's why it is asking me again and again, turn on and do blah blah blah. So this time we are adding this record, so you will see that pipeline will fail. That is why this is the first scenario in my video, because this is super important, and this scenario itself is holding so many little scenarios in itself. That's it is what it is. I can just create multiple scenarios, but what's the, you can say, use case of it? This is not just like clickbait video. This is like knowledge, pure knowledge. So let's see what will happen in our notebook this time. So we know that we have, let's say, 6 records this time. Okay. And we know that 6 records, it is running it. Yeah, 6 records. We have 2 5 IDs. Now, if I run my pipeline, let's say I'm creating this database, data frame. If I try to upsert it, it will fail. Why? Because it will say, bro, let me wait for it to fail. Yeah, it failed. See? Okay, it failed. Okay, perfect. So, by the way, it failed and it ran this. It simply overwritten the data that we don't want. Okay. If it is failing, it simply is running this one. So I will simply switch back to, let's say, if method. Let's say if dbutils dot, then I would say fs.ls, or basically we have, I think, file exist fs.ls, and then we can just simply provide that one. And if we have that one, then it will simply run this. Okay, by the way, that is not the, you can say, directly related to this thing, so we can simply ignore that as well. So let's forget about this. Let's focus on this code only, this one, how we need to just handle that. Okay, so here it is saying, what is the reason of the failure? Let me just tell you first of all. So the reason is, if I click on it, you will see multiple source row matching target. That means it is saying, hey, you want me to update or insert the data based on the ID column, but you already have 2 different values for ID. Which one I need to pick? I don't know which one I need to pick. So we need to tell which one you need to pick. Let me just tell you how you need to handle that. So here you will simply say, hey, let me just dedupe it. So this is our source of this particular upsert command, right? So in your DF, being a data engineer, you need to populate only the latest records. How you can just do that? So basically this is a DF. Okay. So instead of displaying it, you will add one more step to dedupe it. I will simply add it for you. I'll simply say dedupe. Okay. And how you can just dedupe it? You will be using window function, which is called row number. So you'll simply say df equals df dot with column. Okay. And this can be called as, let's say, dedupe column, and then the transformation will be, it will be a window function. I will simply say row number. Okay. And in order to use window functions, you, I think, need to import it as well. So I will simply say from window import window, if you are using window context, otherwise it is fine. Modular name dot from window. Oh yeah, we can simply say import window. What? Are you serious? Are you serious? From, let me just ask it. Import window module. Import window. Oh, yeah, it is the one. Okay. From PySpark.sql window, import window. I was like, what is that module? Okay, perfect. So now what I will do, I will simply say row number. Okay. And then I will simply say dot over. Then I need to specify what will be my partition ID key. It will be my primary key. I will simply say window dot partition by, it will be ID key. Okay. And then I need to perform the order by. So now what will be the order by? Order by will be, first of all, in the descending order, because I want to pick the latest record, and it will be based on updated date. Make sense? Updated date. What is this red mark? What is this? what is this? What is this? What is, I think it is fine. Okay, so now if I run this, what will happen? Let's see. Row number is not defined. Okay. Row number is not defined. Okay. I think I know this. I think we can also import from PySpark.sql.functions import asterisk. This is like boilerplate code that we have to write everything like import, import, import. So let's try this time this one. Okay, a column function with update date cannot be resolved. It is not update date, it is updated date, bro. It is updated date. Okay, so perfect. So this time, as you can see, I got what I was looking for. So this time I can see two different particular dedupe values, 1 and 2. Now, do you know what I want to do? I just want to filter all the records with dedupe ID equals to 1. That's it. So I will simply say df equals df dot filter on the basis of column which says dedupe. Okay, and it should be equals to 1, and then I also want to drop this column which is called dedupe because I do not want to keep it. Okay, then if I say display, then perfect, this is the data frame that I want to use to upsert the data, and you can see that I have the latest value without any kind of duplication, right? So now I can simply run this and it should run fine. And let me just add that if condition because it will simply go to the next stage. And in order to just add if condition, you can simply say if dbutils dot fs dot ls, and then you can just provide the location of that volume. And this is not it. This is not it. We also need to say len. Why? Because this will return a list. And if that list size is greater than 0, that means we have some data. That means we want to use this block of code. Otherwise, use this. I will simply say else. These are the guardrails that you apply in the real world. Okay, that you will never see in the, you can say, tutorials and all those things. So let me just run this. So this time it will simply run this thing. This is upsorting now. Okay, and I should see this upsorting now. Very good. Now if I just query this data, I should see the latest data. And it should return trousers instead of pant. So perfect. This has just returned this thing which is saying trouser. And why it has just returned it 2 times? Why? I think that was a bug. I simply reran the command and now I'm seeing like just 5 records. I was like, how we can just see 5 records? So that is fine. So that is fine. And that's how you just handle upserts in the real world instead of just handling upsert in those normal commands. Let me just take you to the documentation page that you can just read. So this is the official documentation page of the PySpark Delta Lake. Okay. And here you can see all those things that you need to know in the world of upserts. I would say I have just already provided you the condensed form of this knowledge. So if you read this, it's good. If you do not read this, it's still fine because we have covered all those things here. Right? So let's see what do we have next in our real-time scenario. The next scenario, and this scenario says a retail company services. A retail company receives daily sales transaction files, which is very normal, from multiple store locations in an Azure Data Lake folder. Now, why did I use Azure Data Lake folder? Because Azure is very much in demand. I know in most of your interviews as well, you will be just hearing Azure Data Lake, Azure Data Lake, Azure Data Lake. But let me just be honest with you. This scenario will teach you how to handle with all the types of data lake. So do not need to worry. Okay. So instead of reprocessing all the historical data every day, the data engineering team uses Spark structured streaming to incrementally load only the newly arrived files into the Delta table. This ensures timely updates to analytics dashboards while optimizing compute cost and processing time. Very good. So the thing is, you are a data engineer, okay? And obviously you are just becoming a pro PySpark developer. So in the PySpark, you will be very happy to know that we have a concept called Spark structured streaming. Yes, Spark structured streaming is so powerful that you can actually do a lot of things. One of the very good examples is like incremental data processing. And incremental data processing not based on some, you can say, those very simple database tables. No. Incremental data loading based on top of files. Let's say today you have received 1 file. Tomorrow you received 2 more files. Day after tomorrow you received 1 more file. So instead of processing all the files every day, it will only track, and it will track all the files and it will read only the new files. How it can just do that? Obviously, there's a magical folder behind it. It's called checkpoint location, which keeps the track of the new files, and it will only process the files which are new based on the checkpoint location. Now, if you haven't watched my video on Spark structured streaming, I don't know what you are doing, man. Just go on YouTube, just type Spark structured streaming full course Ansh Lamba. That's it. You will find the video. Just a tip, whenever you want to just learn something in the world of data engineering, just go on YouTube, just type the topic and just add Ansh Lamba as prefix or suffix. That's it. You will find the best resource. Okay. So now in this scenario, let's actually master this thing. Okay. Even if you have not watched that video, just make a promise that you will watch the video after covering this scenario based video, and then just try to master Spark structure streaming, because it is really, really important. Okay. So just do that. Okay. And before that, let me just tell you how you can just master this scenario. Okay. And this is our lovely repo, and you can obviously click here. And then you can just click on repositories, obviously. So just click on Ansh Lamba YouTube, and then here you just need to click on this PySpark scenarios. This is the folder that we have created for this particular video. So this is the file that I just created, so you can ignore this. So these are the two files, ordersinitial.csv and ordersincremental.csv. You can download both the files, and then what we will do, we will simply upload these two files in our volume so that we can just load the data, but not together. We will upload it one by one, because we need to see how we can incrementally load and process the data, right? And just a tip, not a tip, I would say, as you already know in the scenario, as you have already seen, we're gonna use PySpark streaming. So you will learn PySpark streaming as well. Okay. If you have not learned, and by the way, if you have not watched that video, what are you doing? Just simply search Spark structured streaming. Okay. Ansh Lamba. You will get the video, and this is the video which is saying PySpark streaming full course big data, and this is an amazing video. This is, I think, 4 hours long full course from scratch, covering all the things in the world of PySpark streaming. And trust me, this is the video that I would be using while learning PySpark streaming. Trust me, it has everything, like all the real-time scenarios, all the different types of triggers that we have within the PySpark streaming, all the window operations, everything. Amazing video. Just go and complete that video, and obviously after this video, okay, just save it. At least just click on like button or just click on save button so that you can just save it. Make sense? Okay. So now what I will do, I will simply click here in the catalog, and then PySpark kata, and then source. Within this volume, we have stream source. So let me just click on upload to volume, and let me just upload those files. So I have uploaded these two files, orders initial and orders incremental, and I want to show you, because I know you will upload both the files. Just upload only one file. Okay. Then just click on upload. So now we have one file at this location. Okay. So now what we're going to do, we will simply create a new notebook, and I will simply say scenario 2. Basically, there are like multiple scenarios within each scenario. So I don't know like whether I should say like scenario 2. I would say scenario category 2, because you know me, like I will be just covering so many things within one scenario. So let me just click here in the serverless compute. So now what we're going to do, I will simply say %md, and then I will say streaming query. Okay. Perfect. Streaming query. So now we first need to create the streaming query, right? So I will simply say df equals spark.readStream dot format. Now what is the format? Format is CSV, right? Format is CSV. Perfect. And then I will simply say dot option header. Where is AI? Just fill the code. Yeah, perfect. And then I will simply say dot load. Simple. And for load, I need to just pass the location, and I will pass it from here. Volumes, db volume, stream source. Okay, perfect. So this is my location. Okay, just remember you need to pass till the folder level, because you have multiple files within that, right? Let me just run this code, and if you have your PySpark fundamentals clear, you know that like nothing will happen, because this is just a transformation. This is not a trigger. Basically, this is not an action, right? Good boy, good girl. So now this is like running. It will take hardly few seconds. Meanwhile, I can write my output query. Okay. So see, nothing happened because this is just a transformation. This is not a kind of action. And in order to, you can say, run your code, you need an action, right? It can be display, it can be anything. Even if I say display df, it will run my streaming query, but I do not want to do that. I will simply say, let's say text, because I want to give this notebook to you. So I will just make it neat and clean. And let's say streaming output. Okay. And here I will simply type df dot write stream. Okay. df dot write stream dot format. I can just save it in the delta format. Why? I will say always and always try to store your data in the open table format, some like delta, Apache Iceberg, hoodie. Delta is the most mature you can say open table format that we have. Why? Because it will actually solve so many problems in the world of big data, because it is already solving those problems, right? Something called as, let's say you want to evolve your schema, which is like next to impossible if you just want to do that with other file formats. Yes, we do have autoloader in Databricks to handle those things, but we are not discussing Databricks. We are discussing, you can say, PySpark, right? So I will simply say dot option. Now this is very important, which is called checkpoint location. Checkpoint location. Okay, perfect. So now what is this thing? What is this thing? I will first of all give the whole location. Perfect. Now what is this thing? I want to know. So checkpoint location is, let me just explain this. So let's say you have your data. Okay, this is your source. This is the destination. Let's say one file came today and this file is loaded here. Okay. And it has recorded that information in the checkpoint location. Okay. Like this. Like this. Okay. Perfect. Now, if the next day, on the next day, we have two more files. Okay. Let's use a different color. Let's say green. Let's say we have two more files. So this time, due to this checkpoint location, it knows that this file is already processed. So we do not need to process this file again. So it will simply pick only these two files. Okay. And usually you can create checkpoint location anywhere, literally anywhere. But ideally you should create the checkpoint location within the target location itself. Okay. So I will create a new folder. Basically it's called stream sync because we have stream source. I will create stream sync, and within that I will create a subfolder called checkpoint. Make sense? Okay, so far so good. Then I need to say dot option merge schema. Now what is this? Basically, if you have your fundamentals clear for Delta Lake or basically any, you can say, open table format, if we want to evolve our schema, we always make it as true so that whenever we have new columns, it will not fail our pipeline. It will simply merge the schema. Okay, then we can say dot table, and then I think dot to table or dot table. Because in autoloader, I think we just write to table. We can just test it. If it fails, we can simply pass dot to table. Not a big deal. Because I usually use autoloader for these things. Autoloader is like one of the best things that we have for streaming, but it's fine. So now we need to pass the location. Okay. So now what we will doing? We will simply say, hey, you need to create a table. Okay. It will be a managed table, right? So we can obviously write this data to a destination as well, basically to a volume, to a data lake, or you can even create the table as well. Choice is yours. I will just try to write this data in the volume itself so that you can see the data as well. Okay. So I'll simply say dot save. Okay. And let's save this data in this. And then within that, I will create a subfolder called data. Okay. Makes sense. So now what I will do, I think that is good. And I'm so sure it will give me an error. I was so sure. We do not have like save. I think we have dot to save, or because I use something different in you can say Databricks autoloader. So let me just click on diagnose error. Let me see what do we have that keyword. Dot start. Oh yeah, it was not save. Dot start. I don't need to see the exact like whole code because I know like there are some similar stuff that we have save start. So perfect. So this will, okay, now what is the issue? Streaming source data frame, files already exist in directory. Depending on the file format, you will be able to create a schema from it schema. Oh yeah, perfect. So very good. This thing is very nice. So it is saying schema must be specified when creating a streaming source data frame. If some files already exist in the directory, then depending on the file format, you may be able to create a static data frame on that directory with spark.read.load and infer schema from it. So in the Spark streaming, we forgot to add the schema. So we should always add the schema based on our file format. Make sense? So let me just show you. So here, let's quickly define the schema for it. And we can simply define the schema either in DDL way or in the Spark way. So basically there are two ways. The simplest way is using DDL schema. So I'll simply say my schema equals then, and the same way I just need to define the schema that I define in SQL. So I can simply check what do we have here. We have order ID, customer ID. Okay, I can say order ID and it will be in integer format, I guess. Okay, then we have customer ID. Okay, makes sense. Then we have order date and amount. Okay, order date, let's say, is of date type, and we have amount. Amount, let's pick float, or we can also pick decimal or basically double, or let's pick it. And here, instead of saying dot option, we need to say dot schema. And here I can say my schema. So that's why you would have seen in the code bases that every time before running your Spark structure streaming, we always run the code in the batch mode so that we can see the data and we can actually perform it. Basically, not perform it. Let me just show you what do I mean. So let's say this is my schema. Okay. And I want to read this data in the batch mode first of all, just to test like my schema is perfect. I will say df batch. Okay. And here I can simply say display df. Display df batch. Perfect. So if anything will break, it will break here. See, it is saying implicit temporary streaming checkpoint location are not set up accordingly and blah blah blah, because this is just a batch mode, not a streaming mode. So you simply need to remove this and that's it. Like this is the code that will be commented out in future, because this is not required. This is just while this is required just for the development purpose, right? So as you can see, like this is working fine, right? So here you do not need this, but it's up to you if you want to include this in your development. Usually what I do, like what I prefer, I usually like to comment it out, but I want it to be included in the notebook. Why? Because let's say you are just troubleshooting something, some errors. So if you know your batch code, you can simply again turn off the comment and you can simply run it and see what is the output of it, right? Up to you. Every developer has a different preference. So I cannot say, hey, just follow my guidance and my things. Yes, perfect. I wanted to show you this particular error, because remember I was just talking about a thing in the video recommendation when I was saying you need to know about the triggers as well. So while just running these things, you cannot use all the types of triggers in this particular cluster. That is the only drawback. Why? Usually we write something called as like this. Let's say dot trigger. Okay, and then I will simply say processing time. Processing time equals 10 seconds. Let's say I usually write this, let's say 10 seconds, 20 seconds, 30 seconds. But when you are using Databricks free edition, you can only use the serverless compute. You cannot use the all purpose compute. So in that particular scenario, you have to use something called as once equals true or available equals once, like once equals true. So what it will do, basically once equals true means it will process your data. Okay, it will just complete the streaming query, then it will turn off the trigger. Basically not turn off the trigger, turn off the, you can say, how I can just explain. So if you are using all purpose compute, your cluster will be up and running if that pipeline is just still running. So what it will do, it will simply complete the processing and it will stop running and stop using the cluster, I would say. Yeah, that's a good way to just explain. Do not feel like we cannot use any other trigger, or this is the only trigger that we have available. No, there are ways to use the triggers, but it is not compatible with this compute. So do not worry about that. Okay. Make sense? Make sense, make sense, make sense. So now here it is running my query, and you will see that it will complete the query and it will stop it on its own without my intervention. See, this is the graph, and obviously this is the point where I can see the data. Okay. And this is automatically stopped. As you can see, it is grayed out. In case of all purpose compute, it will be green. It will be green throughout the video if you are just typing here processing time equals to 10 seconds, 30 seconds. So what it will do, it will keep on fetching new data every time, like after that interval. Okay, make sense? Okay, very good. So it has just written this data here, and I can obviously query this data if I want to. Like, it's up to you. Select asterisk from, let's say, delta dot backticks and PySpark getup within the source, not basically source. I can go to volumes, and then within the volume we have stream sync. Okay, and within the stream sync we have two folders basically. One is checkpoint and one is data. Checkpoint is just for the tracking. Data is the real data folder where we have the files. As you can see, this is the data. So I can simply query this data and I will see just that data only. I hope it makes sense. So this is just a validation step that we are adding here. Perfect, 5 rows. Even if I just run this, let's say, command for one more time, what will happen? And what should happen according to you? What should happen? It should not process any data at all, and we should see only 5 records in our destination, and that's it. That is working fine. Very good. Because of the checkpoint location. Very good. Now you can just try it with, let's say, add one more file in this particular stream source like this. Here CSV, just add one more CSV and it should just process only the new data. I have just shown you the validation step, so it is working fine. Make sense? Very good. Let's see what do we have next. So we have another scenario, and this scenario is one of the hottest topics right now because this is like dealing with semi-structured data, and with the rise of big data we are actually getting a lot of data in the semi-structured format, which is a JSON format. So the scenario says an e-commerce platform receives customer orders details from its mobile application in JSON format, and if you have some fundamental knowledge about web application or basically any API, we receive data in the JSON format, right? So this is also saying the same thing. The JSON contains nested fields such as customer information, payment details, and a list of purchased items. To store and analyze this data efficiently in a data warehouse, you as a data engineer need to work with this nested structure, and this must be flattened into a tabular format using PySpark, ensuring all the relevant attributes are readily accessible for reporting and analytics. Wow. Let me just summarize if you didn't understand the scenario. So basically the thing is, you can just understand this with the help of an example. Let's say there's an API, okay, for batch streaming, for batch processing. For streaming, you can imagine there's a, you can say, Kafka service available on the source side. In both of these scenarios, you will receive the data in the JSON format, okay? And with the rise of big data, you will work more with JSON, and I would say with the rise of AI, JSON is everywhere now, okay? So now you need to process that data. You need to store that data in your data warehouse because you are a data engineer. And the good thing is, with the help of Spark structure streaming, okay, and with the help of normal batch processing, transformations will remain the same. So that is the good news, okay? But how to deal with JSON data is not very easy, but let me just show you how you can just work with JSON, okay? Let me just show you. So this is our JSON file, and I know working with normal JSON structure is very easy when you do not have like nested arrays, nested, you can say, complex dictionaries. No, we are not going to work with those simple JSON files. We have created, basically I have created this complex JSON file that you will use to process this data, okay? Once you know how to process or how to flatten this data, you're gonna master all these things, so do not need to worry at all. Okay, so this is the file that you can also download it, okay? Nice. They are adding so many things. See, go to products and wow, nice. So now let me add another, you can say, notebook, and this will be like scenario 3 or scenario category 3, where we are just talking about JSON. Scenario 3. Okay, so now here, obviously the first step will be uploading the data to the volume so that we can just access it, right? So I will simply click on, let's say, a new directory. Let's create a new directory and I will call it as JSON data. Let's say create. So here I can quickly upload the data file. Okay, I will simply say upload to volume. So this file is selected API data.json. So let me click on upload. So this data is loaded. Okay. So I want to read this data. Perfect. So how I can just read this data? And I will just show you the code and you will say, hey Ansh, it is so simple. But I will add the challenges, don't worry. So let's say I want to read this data. I will simply say spark.read.format and format will be JSON, right? And I will not define anything else, nothing. I will simply say dot load so that you can see like what will happen. Okay, and this is the file. Okay, perfect. Let me say display df. So let's see what it will return. Okay, then we will add some complex scenarios within it and let's see what happens. So obviously it is saying, hey, JSON CSV files are disallowed when the reference column only include the internal corrupt record column. Basically it is not corrupted column. It cannot actually determine like what it actually needs to read. We have defined the JSON, that's fine, but we need to also define the schema for it so that it can actually make it like a data frame. So now there's an option called multi-line for JSON. Is this data a multi-line JSON? Just tell me that thing. If I say multi-line true, just tell me, is this a multi-line data? Tell me. Before even multi-line, let's discuss it like after that. Let me first of all define the schema. I will simply say dot define option infer schema and I will just make it true. What is the reason? I just mentioned about that. What is the reason? I just gave you a hint. So the reason is very common. So we are reading JSON file, see, like this. But this is not the only JSON structure that we get. We sometimes get the JSON structure in the one line only. That is called single line JSON. But this is not a single line JSON. This is a multi-line JSON. So we have to define that particular thing here as well. We need to say, hey, dot option and then multi-line and then true. That's it. Now, according to me, it should work. That is the first challenge that we have just overcome. Okay, makes sense. So as you can see that we have like very complex structure. If you see, we have this customer, you can say parent column. Okay, and within the customer column, we have nested structures basically. See, we have customer ID, location, and so many things. Okay, and then we have this delivery updates and then we have items. So basically we have all these things. Okay, and we have like 1 2 3 4 5 6 total 6 columns, but within those columns we have nested, you can say, columns as well. What if I want to use these columns? What if? How we can just use that? I will just tell you, don't worry about that. Even before that, okay, even, and by the way, just look at this column, delivery updates, order placed, packed, shipped, out for delivery, and all those things. Okay, and just look at the items, item ID and item this, item that, item, like so many things, right? So many things, order ID and then all those things. So the thing is, this is the data only for order ID, this one, order ID ORD001 and then ORD002. So for ORD1, these are all the items that are being purchased. Okay, then this is the customer detail, like who made the order. Within the customer column, we have location details in the form of city and blah 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 blah. Are you getting the point? Like they're like nested columns. So first thing I want to talk about is infer schema. this one, which is this one, infer schema. So actually this particular schema needs to be defined manually sometimes if it is not able to read that. So in that particular scenario, you have to either write your DDL command from scratch, that you will not be doing, I'm so sure, and no one does that. So what is the workaround for that one? So we simply define something called as this data frame, okay, and we simply see like what Spark was able to handle, and I will simply say df.schema. That's it. What schema it has, not with braces, like this. What schema it has prepared for us. So this is the schema that it has prepared for us. So what we do, we simply make tweaks. If we, let's say I want to change this string type to integer type, let's say I want to change it because I will be just expecting some integer type instead of string type. Let's say I want to change this currency column to integer type. So I can do that. I can do that. And you can see by default, it has just picked everything in the string type. As you can see, everything, see, string type, string type, string type, string type, string type. Like some are like in double type as well, but in most of the things, right? Order ID, and obviously they are string, but I'm just telling you. So this was the schema that was defined by Spark because it inferred the schema. But if you want to add some columns, or let's say you want to make some tweaks within your schema, then you have to define your own schema. And this is the most detailed schema that you have. For example, within the customer column, so basically this is the parent column, customer. Okay, then within the customer column, you have another struct type, and within that you have customer ID, and then within that you have this email, and then all those things. So this is like a kind of nested schema that Spark has created for you. By default, it will simply say this is the schema for your PySpark. You can obviously write your DDL command, SQL DDL command, and I know most of you will be writing some DDL command because no one writes this schema now because it takes time, but it is very handy when you just want to have, you can say, more control over your schema. Okay, that's one thing. And that's a quick tip for you how you can just define the schema, because for now you have just like, I would say 15 columns, including nested columns, 15, 20 columns. But in real world, you can have hundreds of columns. You cannot define the schema from scratch. This is the way to define the schema, or obviously to change it. Okay, good, very good. So now the question was, we want to just flatten this JSON, right? So how we can just flatten that? Let's say I want to flatten this customer ID. I can even click on this drop down just to see like what do we have here. Okay, so let's say I want to fetch customer ID. I want to fetch customer email. I want to fetch customer location as well. As you can see, this is a dictionary in itself, but I just want to find this location itself. That's it. Not like city and country, just location. Okay, how we can just do that? Okay, let's say I want to just see the customers. Okay, in that particular scenario, you will use df, let's say df customer equals df dot select, and then this will be your customer dot whatever you want. I want, let's say, customer ID. Okay, and let's say display df cost. So it will give me all the customer IDs. I have customer 01, 101, customer 102. Makes sense? Let's say I also want to add location, customer dot, or basically customer dot email. So I can just flatten that like this. Okay, now if you see in your data frame, you have so many these types of columns. Okay, so I can simply say customer ID, customer email, customer location, and let's say customer location, customer location, customer dot location, and you will find this thing. Okay, let's say I want to go within this location, so I will simply add one more dot, and I will simply say dot city. Make sense? Dot city, simple. And then let's say customer dot location dot country. That's it. That's how you just flatten your schema like this. See, now it is looking so good. So this is just like one part of the data frame. See, we have just flattened only one column. In the, you can say, complex projects, You can even create some functions which will run a loop over these columns and will be flattening these things, but it is not generic. It can never be generic because your function even will not know how many columns you have, how many columns you have within one column, and how many columns you have within that column. So it is like a kind of infinite loop. That is why it is like you have to put some human input whenever you are processing, you can say JSON data, even with, you can say, modular code. That means you are building functions, loops, those, you can say, templates. You need human input. That's a fact, and you need to accept this. So this is customer column. Okay, then let's say I want to use this particular list as well, delivery updates. So as you can see that we have a list of delivery updates like order placed, tagged, shipped, out for delivery. Obviously one person will have all these status, right? Whenever you place an order, you will get like order confirmed, then out for delivery, then shipped. Obviously shipped will come before out for delivery, whatever. Then delivery is taken by your neighbor. So you will, or any auntie living in your locality. So you will see all those status, right? All those updates. So in that particular scenario, how you can just filter that, because there is no dictionary here. See, there is no dictionary here. So in that particular scenario, you use a function called explode. Okay. So here what I will do, this is the part that I have done. So what I will do, I will simply add asterisk here. Let's say asterisk. Okay. df.select asterisk. Why it is giving me red? Why? Maybe because of this. Okay. So what it will do, it will simply select all the columns. Okay. And I can now drop the customer column because I do not want that, because I have already flattened it. Make sense? See, customer ID, email, and rest of the columns are as is. Very good. Now I want to just flatten this as well. How I can just flatten a list? It's very simple. There's a function called, let's say, df customer and then updates. Okay. And I will simply say df cust dot with column and this column called delivery updates. Yep, I want to explode it. So it has written the code for me. So this is the code called explode. So what will happen? It will explode this column and it will drop then this column called customer, which we do not need to drop because we do not have that column. So that is fine. So this will simply explode the column. Explode will simply explode all the items within the list. That's it. To the rows. That's it. That's the, you can say, work of it. And I can even explode this items column because I want to see all the items that we have. Okay. And we do not have any kind of other list. So I can simply say explode this as well. Then I will simply say dot with column. And I can even just add this code to the next line, dot with column. Okay. And then I will say items, explode items. Perfect. We do not need to explode payment because that is fine. And here I can say select because I want to select everything. But I want to drop these two columns that I have just flattened. Not drop because we have not flattened it, we have just exploded it. So why it is showing red? Because we need to import the functions from PySpark .sql .functions import asterisk. Very good. Now let's say df cust and then update it. Let's see. Okay, perfect. So now you can see that we have all the things. If I just talk about customer one, so what do we have in customer one? So in customer one, we have this city, blah, 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 and then order updates as well. See, and now why we are seeing duplicates, so-called duplicates, these are not duplicates by the way. Why we are seeing this thing? Because this is the items column. Okay. And this is the status for this particular item. So as you can see, order placed for this item and this item, then packed and packed this item, shipped, this item, out for delivery, this item, because there are totally two items. If I just see item 1001 and 1002. So they are basically total 2 items instead of 1. So you need to get the status updates for both the items, right? So the person also needs the status basically for that as well. Make sense? So now what you can do, you can even flatten this thing. Let's say items.item ID, item.price per unit, the same steps that we have performed so far. I hope it makes sense, and I hope now you know how to flatten this. Now the good thing is that I want to highlight, if the scenario is talking about streaming, steps are exactly same. If the scenario is talking about batch processing, steps are in front of you. Make sense? Because transformations are exactly the same. That is the power of Spark structured streaming, because that particular Spark structured streaming uses the same API for transformation that we use for the batch. Make sense? So even if you, let's say, working with Kafka data, okay, you are receiving data in the JSON format, it will be JSON string, but let's say you are dealing with JSON data, okay, you can perform your transformation like this. You can transform your data like this, basically flatten your data like this, and then you can simply dump your data in the destination. That's it. That's your whole pipeline for Spark streaming. That's it. Simple, dimple. That's how you build like Spark structure streaming pipelines with the help of PySpark. That's how you flatten it. Make sense? And now you know the power of JSON data. See, there's like so much data that we can just flatten it and we can just store it in the data warehouse. See, that's why the demand for data engineers will be growing in the future as well, because currently everyone is so happy, everyone is playing with AI because they have their data warehouses ready. But when we are just working more with AI, when we are just working more with AI data, getting responses from the AI, building RAG applications and all, who will model those data? Data engineers. So obviously you need to upskill yourself as soon as possible. Make sense? Okay, very good. Let's talk about this scenario will be loved by all the Python lovers. So let me just tell you what this scenario says. In a large scale, by the way, this is like real world scenario. Okay, real world. That means like it goes beyond the interviews because we use it in our real world. So it says, in a large scale data processing project, multiple PySpark notebooks require the same set of custom transformation functions, and you have to agree on this. Because in every organization, there are some functions that will be reused across different notebooks, and you know this, okay? So such as date formatting, null handling, data validation, some more example can be data deduplication, so many things, right? So instead of duplicating the code across notebooks, a Python class is created to store these reusable functions. This ensures consistency, reduces maintenance effort, and improves code readability across the project. Why? Because let's say there is a bug that needs to be fixed. Forget about bug, bro. Let's say you want to just update the code. You just need to update the code at one location, and you can simply use the same code everywhere. Let's say even if you have like 100 plus notebooks. You do not need to just maintain the code. You do not need to update the code in 100 plus notebooks. That can obviously fail us like a lot of things, right? So how we can just do that? I know this is very interesting, and it is really interesting. Let me show you how you can just create a Python class to store some custom functions, and let me just tell you how it will work. We are back on our Databricks portal. So what we want to do in this thing, first of all, let's create a new notebook, and this will gonna be fun. Really? Yes. So let's say scenario 4. Okay, perfect. So first of all, let me just create a good heading. Let's say Python class. Why do we need a Python class? So basically, what is a class? First of all, Python class. Python class is basically, you can say, bunch, or basically a kind of bouquet. In bouquet, we just keep flowers. In this particular bouquet, we keep, you can say, so many functions. So basically, let's say in your code base, you have so many functions, right? So many functions. You need to create a bunch of those functions, and all the similar functions, or let's say all the functions that are like related to each other, you need to put it in a class. That's it. That is a Python class. What is the advantage of it? Because all those functions are interrelated, you can simply create an object on top of your class, and you can use all those functions easily. Can we access those functions without a class? Obviously yes. Obviously yes. There is a way, but Python classes are very handy when you have like so many functions. Just, you can say, for code maintenance. For example, one more thing, let's say you have 50 functions. Sorted? 50 functions. and you have written down a script for those 50 functions, and now you want to use those functions in a different script. Then you would need to import all the functions. But instead of importing all the functions, you can store those functions in a class, and you can simply import a class, and you can simply create a function. Basically, you can simply create an object on top of your class, and then you can simply use any function of those 50 functions, any function. Simple. This is the concept of class. So let's say in your organization, you have some functions that are interrelated, and you need to create a class on top of it, so that whenever you want to use that function, you can simply create an object and you can simply use it. Simple. Simple, simple, simple. That is the concept of class. And by the way, let's ask Google, like, what is a class? That was like my definition as per my understanding. Okay. What is a class in Python? And why do we use it? Oh, let's hear like what this Copilot says. Okay. A class in Python is a blueprint for creating objects. It defines the structure and behavior, properties and methods. Basically, method is just a fancy name for function. Okay, do not get confused. That objects created from it will have. Especially a class encapsulates data attributes. Now, what are data attributes? Attributes are basically the variables. Just the fancy name. Attributes are renamed from variables, and methods are renamed from functions. That's it. So it encapsulates. That means it will bunch them together, all the related variables and all the related methods, that means functions, that operate on that data into a single unit. Okay. I will also confirm one thing. Can we say that class is a bunch of similar functions in Python? Let's say what it says, if it is agreeing with our point. By the way, this is not a very good prompt, so I'm not sure. Not exactly, but you're on track. A class in Python is more than just a collection. So obviously, because this is just like one use case, okay? A class is in Python is more than just a collection of similar functions. It is a blueprint for creating objects and combines data attributes and behavior methods and all those things. And obviously, we can just do a lot of more things with the help of classes. We can inherit those classes that obviously I didn't mention it here, but this is, you can say, bigger picture of class. If you just want to understand it from the layman language, that's it. Okay, obviously you cannot inherit functions. You can inherit classes. Okay, and encapsulation, a class bundles data. See, exact word. A class bundles data, that means attributes, and functions, that is methods, that operate on data together. For example, if you're modeling a car, class might include attributes like color, speed, and methods like accelerate or brake. Reusability, obviously you can just reuse your class easily. Classes allow you to create multiple objects, so that let's say you want to use the same function, same class, but for different objects. One instance, second instance, third instance, and so many other things. Same thing that you would be calling for functions, same thing. Then organization, classes help organize code, especially in larger projects. That's what I just said. If you have a group of functions that always work on the same type of data, it makes sense to group them into a class. Not just functions. Classes are not just functions. While classes can contain methods, which are functions, they also define the structure of data that can include special methods such as init, which are like dunder methods. Okay, so these are the things that we have within class. That means we are almost right. Okay. So basically, you can also understand it from the point of view. Let's say you are playing a game. Okay, so in that particular game, you have player one. Okay, let's say you have a hero. So in that hero, you will be having different powers. Let's say you would have played a game. Obviously, I do not want to take the name, but where we have different players, where two players fight. So one player have different moves. So you can create a class for that particular player, and each function will be representing some moves. But different class can be built for a different player, which will be having different functions. So just imagine you do not have classes and you have 10 functions, basically 10 moves for player 1 and 10 moves for player 2. How difficult it will be to manage those functions. But under class, it is so obvious that all these functions are related to this particular player. That's it. Make sense? Okay. That was a simple crash course about Python classes. See, these things are really important, because whenever you just start working on anything, you need to ask the things like why do we need class? Can we just do the work without classes? Yes. But for bigger projects, no. And what are the advantages using classes? You should ask these questions. Don't worry, not everyone asks these types of questions in the beginning. Everyone just get started with it, but with the course of time, you will be able to understand, like, you need to ask these questions. So do not worry. I also didn't ask these questions from myself when I was just learning all these things back in the days. But with the course of time, you will become mature and you will ask these questions. So do not feel like, hey, I never asked these questions. It's fine. It's fine. It's fine. So let's say we want to create a class based on, you can say, data validation. I want to create a class called data validation. Okay, so this is my class, data validation. So what this data validation class will do? Data validation class will validate the data before I want to upsert my data. It can have some duplicates in my data, like the source data frame. Okay, it can, let's say, use to rank my data. Let's say it can just remove nulls from my column. So it will be a validator, simple validator, quick validator. So instead of just rewriting the code every time, because we know that code will be the same. If I want to dedupe, you already know how to dedupe. I just showed you in the beginning of this video while we were just learning Upserts. So you know that those 4 to 5 lines of code will be the same. So why to just rewrite it? We can simply create a function of it. Before creating anything, we will simply create a function called df_init. What is this function? Basically, it will ask for the variables from the user if we are using anything. Obviously, if we are just building a class, we need a variable called data frame. I will simply say self. Self is the keyword that you have to use with every function, except, I guess, if you are creating there are like some special functions that with which you do not need to use self. And I would say df. Make sense? So here I will simply pick df from the user, and then I will simply define self.df equals df, because whatever you want to use within the class, you will be using called as self.df. Because see, I can also define it like this. Let's say df equals blah blah blah. Okay, let's say df equals this. But if I want to use this df, for example, I am creating df, or let's say variable equals to 10. And if I'm creating any function, okay, so if I want to use this variable, I will be just using it with the help of a keyword called self.variable. Make sense? So what we are doing here, we are simply saying, hey, we have a function that will every time run. Okay, so this function, this is a special function in it. So this function will always be running automatically the moment we create the object of this class. This is the speciality of this function. This will automatically run. You do not need to say, hey, my object dot this function name. No, this will be automatically running. And this can again be your interview question. Okay, like, why are we creating this class? So this class will be running automatically. So what we will do, we will simply fetch the variable, and we will take the advantage of this particular feature. We will simply say, hey, if this particular function is running automatically, we can assign our self.df equals to df. That's it, because we need to just convert that df into self.df, because only then we'll be able to use it. So we simply converted that df into self.df. Now we can use that df anywhere. Make sense? Very good. So now I will simply create a function called, let's say, dedupe. This is a function to deduplicate the data, and I have to use self. And within this, I will simply write, hey, df equals df dot with column. Okay, and here what I will do, I will simply say dedupe, and I will ask the person, hey, what you want to dedupe? I will simply say row number. Okay, and here I can also import some classes. Let's say import PySpark.sql. By the way, the person will be importing these functions within their native notebooks, but just for the safer side, let's say person is not importing these things, we can import it. By the way, this is not a good practice, but we can just do that, not a big deal. PySpark.sql.function, because we cannot be dependent on anything. Import asterisk. Very good. So I want to say row number. Then I will simply say dot over, then I will say window, and I need to import window as well from, by the way, it will import, why it will import, who are you, Ansh? You have to tell it that import window, and by the way, here we need to use from. Okay, perfect. Dot over, and within this over you have to write, let's say, dot window, like window dot partition by, that we write dot partition by, and partition by will be on a column, right? Will be on a column. So what will be that particular column? So this is a good thing. You need to ask this question from the user, but for now we can simply hard code it, but you can enhance this feature. Let's say you will be having ID column in that particular data frame. Okay, then you can simply say order by dot order by, and then you can simply say DESC, and then you can simply say what is the order by column. I can simply say updated date. Again, this column can also be asked from the user within this particular function, like this. Let's say key column, okay, and then I can say CDC column. Simple. These information can also be asked from the user, and you can simply say, you can simply type this thing here. Let's say key column, okay, and then updated date column will be, let's say, CDC column. So this is like now pure dynamic. Then you will simply say, I want to filter my data, df.filter, column will be dedupe, as we know, because this is fixed column, it should be 1, and we need to drop the column called dedupe. Okay, perfect. And then I can simply say return df. Okay, this is like my one function that I have created. Similarly, I can create so many functions. Oh, my mouse. Now I will simply say remove nulls. Okay, I will simply say self, and I can say in which column you want to remove nulls. Obviously we have a function for removing nulls, but I'm just showing you like this way. You can simply say you just want to filter your data frame based on any column. Let's say this should be not null. Okay, so you can simply say df.filter column, that is amount, which can be like, let's say, anything. Okay, and what I will say, these parameters should be the part of individual functions according to me, because every function is unique, right? Perfect. This should be like this. We should only ask df in the main class, and then we should ask the independent columns here. Let's say null column. Here we can simply say column equals to null column. Perfect. This should be is not null. Make sense? Then you can simply say return df. There can be like some complex logics as well that depends upon your organization requirements, what they want to achieve, whatever they just want to achieve, whatever code they are writing in a, you can say, repetitive manner, and you can simply create this class. So let me just run this cell. Perfect. So let's wait. So this is a class that we have created, and we can just use this class for our data frame just to check it. Make sense? Make sense? Make sense? What is this? Import asterisks only allowed at a module level. Module level? Okay, I was thinking the same, like if it will be required or whatever. No module named PySpark. Wow, PySpark. Perfect. So now. Oh, one catch. By the way, we didn't see that error, but I know that can be the error. So we are not using self.df, right? We need to say self.df. Perfect. Now it is fine. And here it is fine because we just need to use self.df in the beginning. Self.df dot this thing. Okay, makes sense. And column and window is fine. Let me just use it like this. Let me just run it one more time. This is fine. Okay, so perfect. Let me just run this. So this class is created. Let's test it. Let's say I want to create a pseudo data frame. It can be, let's say, spark dot create data frame, spark dot create data frame, and then let's say just add this 1 2 and blah blah blah. Okay, this is the data. And by the way, let's first of all see this data frame, bro. And what is the schema? Schema is order ID, order date, and amount. Okay, let's say display df. I want to first of all show you the data frame before passing into our you can say class, Python class. Let's see the data first of all. And you can literally see sky is the limit for this class. You can even, let me just give you a hint or basically a homework that you can just try. You can even create a function for upsert logic. Remember, we were just writing the same line of code basically based on the merge condition. You can simply create a function here, and instead of writing those complex logic there, you can simply import this class there in that notebook, and boom. Okay, so this is our data frame. Let's say I want to deduplicate it. By the way, we do not have any kind of duplicated value, so let's add one duplicated value. Let's repeat this particular value here. Perfect. Let's see. Perfect. Now we have a duplicate. Now I want to remove this duplicate based on the order ID column. I will simply say CLS object equals data validation. Okay, data validation, then df is my, you can say, parameter that I'm passing. Okay, let me just run that. So this is my object, this is my instance. Then I will simply say I want to create df dedupe based on CLS object dot function, which is called dedupe, and I want to pass two things. The key column is, I know that it is order ID, so I will simply say order ID. Okay, and the second parameter is the CDC column, which is, you can say, order date. And by the way, we should have order date greater than this so that it can decide like which is the latest value. Okay, so I can simply say order date is second, maybe. Yeah, let's say order date is second. Let's change it here and just change the price as well so that we can see if it has picked the latest value. Okay, okay, good. Perfect. Let's see the data this time. Perfect. Now what I will do, I will simply pass order date. Okay, perfect. So let's create this and let's see if we have any errors, because we obviously didn't test anything. We simply created the class. But let's see if it is working fine. Oh, it is working fine, man. See, now I do not need to rewrite the logic for deduplication. No, I can simply perform this thing using a class. See, because I have created the function within the class and I can just call it and dynamically, see, I'm not hard coding anything. Every key column and CDC column is coming from the user. That's how you create the class, and that's how you create, basically you make your code modular. Bro, do these things in your organization. Do this. What are you doing? Everyone is writing those static code. Everyone is writing those code, right? And even AI can write this code. I can simply go to this button and I can simply say, hey, I want to dedupe this thing. Let me just write it for you. Let me just show you. Let me just show you, bro. You are not. I want to dedupe my data frame based on the, let's say, order ID column. Okay, so my class is so good, even AI is using that. Bro, don't use my class. It's personal. Let's see. Okay, see, the whole code is just in front of me in just 1 second. So why you are just writing the same code that AI can write? Now you will say AI can also write those classes. You are wrong, my bro. No. You know the requirements of your organization. You know how you need to just handle those parameters. Yes, AI can help you in writing or building those classes, but it cannot directly write it. So instead of writing the static code, you need to think it like this. That's why I have just added this particular scenario in my video so that you can understand it. Okay, make sense? Now let's talk about this particular scenario. And trust me, this scenario will be really, I would say, the most helpful scenario in this video. So let's talk about this scenario. This scenario says a retail company maintains a product catalog in its data warehouse. Okay. Product details such as name, category, and price may change over time due to rebranding, category updates, or pricing adjustments. But don't worry, this is not similar to the Upserts. This is something else. So basically, to preserve the historical data for accurate reporting and trend analytics or analysis, the company needs to implement a slowly changing dimension type 2, not type 1, type 2 mechanism in PySpark, ensuring old records are retrained or basically retained, not retrained, retained with effective date ranges while new versions are inserted as separate records. Did you get this? Let me just explain this scenario with the help of an example. Let me just show. So let's talk about slowly changing dimension type 2. And let me just show you what is that particular thing. I know in most of the cases, this will be the, you can say, most talked about, you can say most talked slowly changing dimension, because I think in total we have 6 different types of slowly changing dimension types, but type 1 is like very easy to implement and you will be using type 1 in your silver layer. But when you are building actual dimensions, you would be using type 2 a lot. You will be saying, what about the other types? They are not actually used a lot, and type 3 will be used a little bit in rare scenarios. Type 4, type 5, type 6, I myself have not used it, so you can simply ignore it. Okay, so let me just show you what is slowly changing dimension type 2. Just a quick intro if you do not know about it. If you know, obviously bro, you are a pro, I know. So the concept is very simple. Let's say you have a dimension that looks like this, in which you have, let's say, source ID, first name, last name, region. Okay, this is the table. This is the source table. If you want to convert it into a dimension of type 2, then you will simply add 3 more fields. And the fields look like this: start date, end date, and is current column. What does it mean? So let's say whenever you have any new value for any kind of ID, let's say in the source ID, you have something called as 3. Oh, wow, my handwriting. So let's say 3, 3, and 2. Okay. Then what it will do? It will simply insert the record in this particular dimension. But do you know what will be the start date? What will be the start date? Just use your common sense. Obviously, start date will be the date when this data is inserted. But what will be the end date? Now there are 2 options in the industry as well. We use one of these 2 options. End date will be the date which is so far from now, which is so far. It can be, let's say, 9999 1231. Okay, very big date. That means that is a clear indication that this particular record, this particular ID is in use. It is not expired. So end date is also called as expiry date or expired date. Make sense? So either you can keep it a very big date or you can even keep it null, because there is no end date for this record if that record is in use. Make sense? Then this is the flag which is saying is current. That means this record is in use right now. It can be called as is current, is use, is in use, whatever. Make sense? Let's say after 2 days, I got some other value for this particular ID 332, and instead of first name, the name looks like this. Let's say ABC. Okay, so do you know what will happen? We will not simply upsert this record. We will simply not update this value. No, because we want to keep the history. We will simply say, hey, this record was inserted at this date, but now we will simply add an expiry date, real expiry date, the date at which this particular record was updated. That's it. And we will simply say this value is not in use because this value will be in use instead of this one, because this is expired, right? But we do not want to just remove it or replace it. No, we will keep the history. That is the concept of slowly changing dimension. Type 2. I know you have not understood 100% of it. Why? Because I have just mentioned the theoretical part. Now I'm gonna just show you how you can just build slowly changing dimension type 2 using PySpark, pure PySpark, and then you will understand 100% of it. I promise. I promise. And if you understood the concept, okay, then you need to just drop a lovely comment on this video, and I know you will, okay, because I will make you understand. Don't worry. So let's go back to our PySpark, PySpark. Okay, PySpark real-time scenarios. And by the way, what is this? API creds. I was just testing something, so I can simply delete this. Okay, I can simply delete this, so do not worry. Hey, what is that file? What is this? Don't worry. So let me just create a new notebook, and let's call it as scenario 5 maybe. Okay, so this is my notebooks from previous videos. I was just having a quick look because I was just about to talk about SCD, so I was just gaining some reference. Scenario, wow. Scenario 5. Scenario 5. Perfect. So now what we gonna do? We gonna create this scenario. Okay. So in order to start working with story changing dimension, we should have at least a source table ready for it. Make sense? So let's actually see if we do have any kind of source that we can use, or let's create a new one from scratch so that you can understand it from scratch. Let's say I want to create a table. It's called create table, and I want to create table in PySpark kata dot source. Let's say I want to create a slowly changing dimension for customers. Okay. Okay. Source dot customers makes sense. Customers, bro, customers. Perfect. In this, I will be having ID, okay, which is of string type. Then I can have name, email, city, country. Perfect. I think that is enough. Okay. Okay, perfect. So this is my table. Let's create this. Okay. And let's insert some data. Insert into PySpark kata dot source dot customers. Okay, bro, why are you writing products again and again? Then I can simply say values. Okay, perfect. Now I will define the values. Okay, now 1 and New York. Nice. I love New York. Really? Who lives in New York? Who? I don't know. Sarah Jones. Tokyo and all. So these are basically 5 records. I'm just kidding. No one lives in New York. Obviously a lot of people live in New York, but I don't know anyone. So source.customers, that is fine. Okay. So let's insert these records, these 5 records. Okay. So this is my source, and let me quickly query the source. Select asterisks from PySpark kata dot source dot customers. Perfect. Why it is showing red mark? Why? Okay, so we have this data ready. Very good. Do you know what we need to do now? We need to prepare our end table. Okay, how we can just prepare that? Obviously by using that if condition. Okay, so what I will do, I will simply write if let's say, so we are creating a table, right? We are creating a table. Let's say you want to create a table. Okay, so now you can use spark dot catalog dot table exist. And what is the name of the table? Name of the table is PySpark kata. PySpark kata dot source schema. Let's keep the schema same. Then this is a table name which is called dim customers. Okay, if this table is there, that means if it exists, we will write our code. For now I'm simply writing pass Then if table is not there, we need to create, basically this table needs to be created, right? So I'll simply say spark.sql. Let's run spark.sql command. Okay. And then I can simply say not create table basically, because I simply need to keep it very simple. Okay. So now what I can do, I can simply say select asterisk. Select asterisk. I think I can write something like this as well. Create table. If not exist, like this. Okay. And this will look like this: ID, string, blah blah blah. But I do not need to actually worry about this thing. So I can say dim customers. Okay. Then I will say select asterisk from source, because I just want to copy the source data, right? PySpark kata dot source dot customers. Okay. But that's not enough, because we need to add 3 more columns if you remember. So I will simply say I want to add something called as start date. And what will be the start date? What will be the start date? Start date will be obviously current timestamp. So I'll simply say current timestamp as start date, or basically start time, because this is a timestamp. End date, what will be the end date? End date. So end date will be very big date. I will simply say cast. Okay. Cast, let's say 3000 0101. Okay. As timestamp. Okay, perfect. And I will call it as end date, end time basically, not end date. So this is my second column, and then I will say yes as you can say active. Active can also be a good name, or you can say is in use or is active. You can use anything. Let's say is active. Okay, so these are 3 columns that I want to use. So these will be added along with this one. Okay, so let's actually run it and let's see if we have any errors. We should be ready for the errors. That's fine. Okay, so this ran successfully. Okay, so now let's see if we have successfully created that table. We'll say select asterisk from PySpark kata dot source dot dim customers, right? Perfect. Let's see if we have anything. Okay, perfect. We have everything that we want. Okay, ID, email, city, country, and along with those 3 columns. Very good. So now our initial setup is ready. Now we want to add our main code here, and this will be lovely code, trust me. Before writing it here, okay, I can just show you how we need to perform, because it will be a complex code. But obviously competition is high, so I have to just tell you how we can just develop, you can say, story chain dimension type 2. Okay, so let's write the code here. Let me just say std type 2. Perfect. So first of all, do you know what we need to do? Yes, your base is ready for story chain dimension type 2. Why? Because you already know the basics and fundamentals of upsert command. In this, we'll be using upsert command, but with conditions, with logics, with conditions, more logics, and multiple times. Don't worry, let me just tell you. First of all, I will simply say what is my source and what is my destination. Simple. So now my destination is this table, this one, which is called dim customers. Very good. So I have that destination. What is my source? Source will be, I have to create the source. Source will be, let's say, spark.sql. Okay. And then I can simply write the source. Select asterisk. Okay. Select asterisk from PySpark.keta.customers. Okay. So this is my source. This is what? This is my source. Very good. Now this is a df, and you know that we have to dedupe as well if we have any duplicates. You already know this, right? Very good. So what I will do, I will simply say df And I can even use our class. If you remember, we created this class. Where is that class? If I go to scenario 4, so we have this class, right? Oops, I just commented it out. This is the class. I might have commented it out, so you do not need to worry at all. So this is the class that we have. Okay, and we can actually leverage this class. Do you know how and like what we need to exactly do? It is very simple. In order to import this class, okay, first of all, you can say write this whole class into a dedicated Python file called .py, and then you can import this class into your code. But you know what, I do not want to do that because you will be distracted and your focus will be distracted from the switching dimension type 2. So let me not do that, but I have just given you some hint or basically some good tips that you can do. Okay, and once you understand switching dimension type 2, you can try it with this class as well. Just import it because that's why we created this class, right? Okay, very good. Good boy, good girl. Okay, so now I will simply say df equals df. Now you know the importance of that class, right? See, I'm again writing my code, but with the help of that class, I do not need to write that code. Smart. Okay, so df equals df dot, then we need to simply say with column name will be dedupe, and then obviously we need to import the functions PySpark.sql function import from PySpark.sql.window import window. I also want to import delta.tables, import delta table. Okay, perfect, bro. Okay, so dedupe, and here I will simply write row number. Okay, then I will simply say dot over, then window dot partition by customer ID. Partition by, wow, partition by on ID column. Okay, then dot order by. You will ask, hey, why do we use window with partition by and not with order by? Basically, we are using window with both, but if we are writing window here, it is automatically transferred to order by as well. But if you do not write partition by, you have to add window with order by as well. So just a pro tip. Okay, good boy, good girl. DESC. Okay, then DESC on like which date you want to just save this data. I would say start date or basically update date. Ideally we should just do it on start time, but you know what, we should have created one date called modified date as well. Ideally, like whenever we just create this table, ideally we should have that, you can say, modified date. Why? Because these three columns will be created on our end table, basically on the final table. But in order to just dedupe the data, we should have that particular date column in the source itself. Really, yes, it is, which is called date modified, like when this data was added. So we need to fix this, otherwise you will not be able to understand it. So what I will do, I will simply say drop the table, and this is a manage table. So when I say drop table, this command, this one, okay, when I run this command, that means that data which is stored in this table will also be deleted. But in case of external table, you first need to delete or basically drop the table from the catalog. Then you have to manually drop the files from your external table, because that is the advantage of external table. Okay. Okay, sir. Okay, ma'am. Okay. So let's say modify date. Okay, and this will be timestamp. Perfect. Let's create this table and let's add the value as current timestamp. Current timestamp. Perfect. Okay. Current timestamp. I want to add this here as well. Then here as well. Then here as well. Then here as well. Perfect. Let's add this data. Perfect. Let's see how this data is looking right now. Okay, perfect. Now we have modified date, which is really important. Wow, I'm really thirsty. I want protein. So now let me just run this command and boom. Let's see if we have that particular column. Perfect. We have that column. Where is that column? Ooh, where is that column? We have select asterisks. Okay, we have modified date here from customers. From PySpark kata.source.customers. Okay. So I think this command actually didn't run, obviously, because this table already exists. We didn't drop this table. Okay, we first need to drop this table. PySpark kata.source.dim customers. Perfect. I was like, why? So this table was not dropped. So now let's run this. Now it should create this table like this, and let's confirm if it has created it. Perfect. Now we have modified it. Perfect. Because we need to understand everything. We cannot just like complete it. We need to understand it. Okay, perfect. So now let's redo bit based on the modified date column. Okay. Perfect. So this is my DF. Just to show you how a display DF looks like, let me just query this. Perfect. So this is my data frame. Okay, very good. Now, do you know what we need to do? Instead of display it, I will simply say df dot create or replace temp view, because we need to convert this df into a temporary view, which will be called as, let's say, source. Okay, makes sense? Perfect. So this is my view now. Okay, very good. Now we will write our merge condition. So there are basically two merge conditions involved. Condition number one, let me just type it here and just listen to me carefully, and it's possible that you will not understand it in one go, so just rewatch this part again and again. Don't worry at all, because when we were also learning, we were also watching these things again and again, so it's part of the cycle, bro. You have to just do it. I will simply say marking the existing, or basically marking the updated records as expired. Perfect. Wow. Marking the updated records as expired. Okay, so now what will happen? I will write my merge command. I will simply say merge into, and just change it into SQL. Okay, merge into dim customers. Okay, using my source. Okay, basically this is another way of using merge condition. And whenever we are building slowly changing dimension type 2, it is always recommended to use SQL command to merge instead of Python, because in Python API you will have to just write so many conditions, which is not ideal, because you will be just comparing all the things. So it is always good to handle it with SQL command. Perfect. Now I will simply say merge into this dim customers, and I can simply say dot alias, or I can simply say dot .trg. Okay, and I can simply say as src. We can just correct it if it is wrong, because I really use SQL, you can say, command. It is fine. Then I can simply say on trg.id equals src.id. Now this command will not be that much simple. Okay, we have to write one more thing, and trg dot is active equals yes, because we have to pull only the valid records which are already expired. We do not need to worry about that. Okay, now we will use when matched. When matched, we will not say when matched then update. No, see, this is my data. Where's my data? Let me just query. I think this is the data. Yeah, source. So this is my data, right? This is my data. So let's say I am having this ID1 again in my next batch. Okay, if the data is same, that means email is same, city is same, country is same, modified date is same, everything is same. Do I need to mention it as expired? Obviously no. So that is the thing we will be doing it here. We will simply say when matched and, okay, when matched and source dot, you can say any column. It can be, let's say, basically all the columns, email, city and country and modified date. Email, city, country, modified date. Just remember these 4 columns. Email not equals to trg.email. What does it mean? That means email is changed. Okay, then you will simply say or src.city not equals to trg.city. That means city is changed. Then src.country. Do we have country? Yeah. Or modified date. Perfect. If we have, okay, if we have any of the values changed, that means we need to say, hey, just make this record as expired. Why? Because we have an updated data. Then we'll simply say then, let me just go here, then you will simply say update. Okay, and now you will say set. You just need to set 2 things. One is trg dot end date, or basically end time, equals to current timestamp. That means at this moment this record is expired, and I think you just need to use comma. Okay, and then you will simply say dot trg dot is active. That means this record is not active now. Perfect. That's it. You do not need to talk about when not matched and blah blah blah, because your first merge condition will only and only mark the records as expired. I can also say merge one. Perfect. Merge one, marking the updated records as expired. Perfect. Let me just run this and let's see what happens. If everything is fine from the syntax point of view. No, dim customers cannot be found. Verify the spelling. Oh, I know the issue. So we didn't mention the catalog and all. PySpark kata dot source dot this. Perfect. So let's see if we have any errors. No, everything is fine. So that ran fine. This is only the 50% of the, you can say, dimension. Now we have simply marked the record as expired, but now we need to insert the records, which are obviously not matching. That means the records, let's say you have id equals to 6, that means that id will not match, right? We need to insert the record. But as we talked about this id, which is id 1 or 2, basically whatever id, even this id is being updated, we need to insert it, because we are not simply updating the value, because we have already marked those records as expired. So we just need to insert those records, and that's it. We do not need to say, hey, if this id is matching, then update. Now one quick question some of you can ask, okay, that is a very smart question. You will simply say, Ansh, if I have, let's say, the new data in the form of 1, okay, and 6 is fine, this id is not matching, this will insert the data. But how this id equals to 1 will insert the data, because this id is already matching? Very good question. So the answer is, we will not pull this id. What do you mean? Because we will simply add the condition which says active equals to yes. But this time when this will be running, like basically this second merge condition will be running, this active flag will already be no. Do you want to see it? Let me just run this command and you will see it. If we have new data, obviously we have not run that. So we have here yes. When you will be running for the next iteration, you will see that. So at that time, you will see here n. That means this record will never be compared. And if it is not being compared, it is a new record. So it will simply add that. So we know that this record is there, but Spark doesn't know because we didn't actually pull this record because of this flag. That's it. Make sense? Let's do that as well. I will simply say text h3 merge to, okay, and inserting new plus updated records. Okay, makes sense. So now how we can just do that same thing, merge into, and whatever your name is, dim customers, using same source. Okay, I can simply say src, I can say as target, okay, on, as you know, src.id. okay, then I can simply say when not matched, and here I need to also add that condition, add trg dot is active equals to yes. Okay, perfect. When not matched, how you need to just insert all. That is a simple thing. Okay, then insert asterisk, and that's it. Because we simply need to insert everything, but we cannot insert it directly. Why? Because see, you will be inserting those records with your custom values as well, and that is already there. So I think this should work, that insert asterisk, that is fine. When not matched and insert asterisk. Now what is this thing? When, okay, on ID is this and ID is this one. So we are simply saying when not matched, then insert asterisk. Okay. I think it should work. Let's see if we have any errors. Okay, I see what are the errors. So we didn't change it to SQL. Perfect. So this thing cannot resolve start time in insert clause given source.id, source.this, source dot cannot resolve start time in insert clause. Okay. Oh, see. So we have to manually insert the records. I was sure like this will throw an error. So basically the thing is, it is saying how we can just configure the start time in insert clause given source ID, source email, source city, source country, modified date, dedupe, and that's it. We do not have anything regarding those particular things. So what is my source? If I see my source, which is this one, so we do not have those values. Why? Because we actually didn't add those values here. See, where is my source? Here. See, this is the source. So this source is actually incomplete, and that is a very good catch that we are seeing it here. So the thing is, we haven't added the values for those three columns. So I will simply say df equals df dot with column. Okay. Then I can say, or you have basically two options. You can even insert values in this particular source view as well, which is up to you if you want to do that, but I want to just use this column. So I will simply say start time. Okay, because see, we are using source as is from customers, and in customers we do not have those three columns. We created those three columns here, if you remember, in the else command, but we also need to do it for the rest of the iterations as well, right? So we just need to do the same thing that we have done it here, same thing. So that is why I told you we have two options. We can either use the same statement just to keep the things easy for you. So I will simply say, hey, this is my source, and let's add this source. Let's say this is my source temp, just like temp. Okay, and then I can create this new source for you, spark.sql, and just copy paste it. Perfect. So this is my source. Okay, And here, instead of writing create table, you simply need to say select asterisk from source temp. Make sense? From source temp, and this is the source temp, like here. Okay, so just do this. And why it is throwing red? Because this is not created for now. It will be created. Okay, and once it is done, like once it is done, then you can convert this into source. tf dot create or replace temp view, and you can say source. That's it. Everything is fine, and we can obviously test it. And I can simply show you the value now. Select asterisk from source, and you will see those 3 columns. Perfect. See, and we can just get rid of this dedupe. We do not need this dedupe, and I can add dot drop here. See, it is not very easy to create slowly changing dimension type 2. So if you are thinking, hey, it is very complex, the answer is yes. But is it impossible to create? No, I am there for you to help. So just follow along, and that's it. And let's query this for one more time. And this is perfect. Perfect. This is the data that we want to send it as our input for the merge condition, right? We can also run this just to make sure everything is fine. Okay, very good. So now we can perform this second merge as well. Perfect. When not matched, then insert asterisk. Very good. I just want to query the data. Okay, just to show you how our data is looking right now. Perfect. Let's see. So these are the records. These are the 5 records, and these are the values so far. Very good. Now, do you know what we need to do? We need to simply test our logic. Let's insert some new records. I will simply say insert 2 records. First of all, change the city from New York to, let's say, Seattle. Okay, and then just add a new, you can say, ID. Okay, let's insert these 2 records in our source, and let me just show you how our source is looking right now. It should have the new records. Perfect. It has 1 and 6. Perfect. Now we simply need to copy the whole logic. The whole logic. Do you know where? In this code cell, basically here. You can do it later on, but we just first need to test it before pasting it here. So I'll simply skip this, and I will go here, and this is our current condition of dimension. What we are expecting? We are expecting 2 records for one record should show as expired, and 1 record should be new, right? Let's run that logic. So this is the first code cell. Okay, this is fine. This is the source. Just make sure like everything is fine. Okay, this is the code. Okay, and it has picked that particular code as okay. So did it perform dedupe? I just want to see that. Okay, actually not, because we didn't add the filter here. That's a very good catch, Anshlamba. df equals df.filter. If you would have figured it out, I know you are smart enough. I know. So let's do this, and let's see if we have now dedupe data. Dedupe df dot filter column dedupe. Perfect. Now let's see. That's why I always add these select statements, just to make sure like nothing will break. Okay, perfect. Now you can see that my data is deduped, and this one ID is having basically new kind of city, basically Seattle. This is a new city. This is a change that I want to make. Okay, so now let's see what will happen in our merge condition. First of all, we will run our first merge command, which will basically make the records expired. Okay, and then in the second command it will insert those new records plus updated records. Okay, let's wait. Okay, now let's test, fingers crossed. Now let's see if our dimension type 2 is ready. Okay, it's ready. Okay, as you can see we have two records for one, but first record is expired. As you can see, is active is equals to no. That means this is expired, and we have the date as well when it was expired, and we have the second record with the endless date, and this is currently in use. Perfect. So we have our storaging dimension type 2 ready, and I am really happy. So now we can actually merge our all the code. Okay, or you can keep it as it is if you are learning, because you will see these two commands, merge one, merge two, and here you can simply say pass, because it will not break the pipeline. It will simply skip that particular code, which is this one, because we have pass, and then it will go to the further code cell. So I should just keep it like this so that you can learn and make notes. Otherwise you will not be able to make notes, and you will not be able to understand it if I will just consolidate all the code inside one, you can say, logic. Makes sense? So very good. I'm really happy that you learned how to create storaging dimension type 2, because this is, you can say, non-negotiable. You cannot negotiate while, you can say, building this thing. Okay, this is non-negotiable. Okay, very good. So now let's see what do we have as our next scenario. So now let's talk about the last scenario of today's video. This scenario is very new, very new in the world of Apache Spark, especially because I was just reading one article in which it was written like something related to that Databricks Delta Live tables are now being added in Apache Spark. Okay, something related to this was written. So that means Delta Live table pipelines are becoming more and more important after that, because earlier it was just only subject to Databricks, but now it is, even if it is not like contributed to Apache Spark, I would say it is directly related to Apache Spark. Trust me, it is very new. By the way, I have created the dedicated video on Delta Live table pipeline. You can simply go on YouTube and just search Databricks declarative pipelines full course, then just say Ansh Lamba and you will get the link, and this will talk about everything in the world of Delta Live table pipelines. Okay, so but still we need to just cover this scenario in this particular video, because our video will be completed after covering this scenario. Okay, so this scenario says a retail company processes daily sales transactions from multiple store locations. Data arrives in different formats and needs to be cleaned, obviously, validated and aggregated for business reporting. Using a Delta Live tables, basically DLT pipeline, the raw data is ingested from cloud storage. In this case, you can say managed storage, anything. Then transformed with quality checks, this is important, and stored in the Delta tables for analytics dashboards, ensuring accuracy, reliability in near real time. So in short, we need to create a Delta Live table pipeline which will make sure that data is ingested from the raw location, it is transformed, and we also need to apply some quality checks before writing this data to the end table. And all of these things will be done only and only by Delta Live tables. Are you excited to do that? Let me just show you how you can just do that. And I know Delta Live tables is a very new concept, but it is the right time to master it. Okay, and if you already know something about Delta Live tables, then you're gonna love this scenario. If you do not know, then you have to watch the video, and I will just provide the video link in the description, maybe in this I button, and you can just simply click on that video and just master Delta Live tables. What are you doing, bro? Because Delta Live table is the hottest topic right now. Okay, let's see what do we have in this particular scenario. Let's see. Okay, so in order to create the Delta Live table pipeline, we have to go to, let's say, first of all, to the home page. Okay, and here we need to go to jobs and pipelines. First of all, I will delete all the jobs, because of the free compute you cannot actually create multiple jobs in one time. So if you also have some jobs built in your workspace, I will recommend you to just delete them if you are not using them. Okay, so now the scenario is very simple. We have a source table. Okay, and this table can be anything. Let's say we have dim customers table, like it can be anything, right? It can be anything, so we can just use literally any table just for the example. So let's say we are trying to read customers data. Okay, customers data, very good. We need to transform this data, and we also need to perform quality checks before writing this table. Okay, perfect. So in order to do that, first of all, just go to settings. Okay, and just go to developer settings, and just make sure that you have enabled this button which says, I think, Lakeflow pipeline editor. Perfect, because I'll be using modern UI for this because I love that. And I will simply go to jobs and pipelines, and then click on create and click on ETL pipeline. Perfect. So this is my user interface. It is saying, hey, what will be the new pipeline, blah blah blah. I will simply say start with sample code in SQL, not SQL, Python. Okay, so this will open a kind of, you can say, modern UI for me for DLT pipelines, and I love this setup. Okay, first of all, I will move this folder to my main folder, which is anshlambacollab within PySpark scenarios. Okay, and then I'll simply say move. Perfect. So this folder is now moved there, and I can also rename this root folder. Rename. Okay, perfect. I will simply say DLT tutorial. DLT tutorial. Perfect. So this is my folder name, which is raw folder. These are some sample files that we will be deleting because we are not running this one. Okay, perfect. By the way, you can just watch my complete video on Delta Live tables. I can just show you. Let's say Databricks declarative pipelines. Okay, full course, and this is the video, Databricks pipelines, and this is, I think, 3 to 4 hours video course, and this will make you, I will say, job ready. Okay, this is also called as Databricks declarative pipelines, or you can say Delta Live tables, or you can say Databricks pipelines, whatever you want to say. But this is the video that is a masterpiece. That is a masterpiece, trust me. And I think, what is this link? I think, oh, this is my video. Okay, good. So you can actually watch this video. Okay, and this is an amazing video, and this will just teach you almost everything that you need. Okay, so let's suppose you know a little bit about DLT, then let's continue with this scenario. And obviously, if you do not know about this thing, you can obviously watch that video. So I will simply click on this 3 dots, and I'll simply say create file, and I will simply create let's say first.py. okay, and here within this I can click on this graph just to have more space, and perfect. And this is my pipeline name. I can simply say DLT tutorial. Usually we should keep the pipeline name same as is our root folder name. Just a good practice. You can just keep anything else, but just a good practice. So first of all, I will simply say import DLT. Oh, let me just adjust it. Perfect. So I will simply say import DLT. Perfect. So now I will be creating something called as streaming table on top of my source table. In order to do that, you use a decorator .dlt.table, and I will simply say name equals, let's say, customer staging, or let's say customers raw. Okay, and this will say def, obviously customers raw, return def cust, because we do not perform any transformation for the raw layer. Okay, then I want to create a transformed layer. I will simply say dlt.table, and this time I will say name equals customers transform, or basically enr, that means enriched. Okay, and I will say def and then customers enriched, and we will perform some transformation. Let's say I want to dedupe this data in this particular transformation stage. Okay, so I can simply bring that dedupe logic, as we all know that df dot with column. Okay, then we have something called as dedupe, and then row number. I can import that particular thing here as well. Perfect. I will simply write this logic, row number dot over, then window dot partition by. Okay, and then id, then dot order by. Perfect. So this is my data that I want to return. Perfect, 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 perfect. This is my transform layer. Okay, now I also want to create the gold layer, basically curated layer. Okay, I can just do that, dlt.table, and name will be customers underscore cur, which is curated, which is fancy name for gold layer. Okay, I will simply say def. Now the thing is, see, I can create a dimension as well, slowly changing dimension type 2 directly using delta live tables. Really? Yep. For that, you just need to create an empty table, dlt.create streaming table. Obviously, we are not discussing delta live tables in detail because that is already discussed in a dedicated video that I have just shown you. Just watch this scenario, feel excited, and just complete that video for delta live tables. Okay, very good. Create streaming table, and then I will simply say name equals, let's say, customers dim. Okay, so this is my empty streaming table. Now I want to use something called as dlt dot create auto cdc. Basically, this is a kind of API that we use in order to just do this. So I can also show you the documentation for cdc, auto cdc flow Databricks. Just click on anything, maybe Microsoft page or AWS page, whatever you want to pick. So this is the page that we just configure. So I can simply copy and paste this particular code from here, dlt.create auto cdc flow, and you just need to fill those boxes. That's it. So it is saying, hey, what is a target? Target is this my empty table, this one, and you can also encode it in this one, like this, like this, and like this. By the way, this is optional. We can also pick this name as our table name by default. Okay, so this is my target. Target is customers, okay, dim. Very good. Now what is the source? What is the source? Like, what will be the source that will be being ingested in the table? I will simply say customers enriched. Key column is very important. Key column is basically the primary key, which is id. Okay, sequence wise very important, because if we have duplicates in our source, it will automatically handle that. That is the best thing for DLT, slowly changing dimension type 2. I will simply say modify date. Perfect. Ignore null updates and all those things. I can remove it because I do not want that. Accept column list. This is helpful when you just want to accept some column, but I want to just keep it as it is. Stored as scd type 2. That's it. Perfect, perfect, perfect. So that's what you want to configure, and this is your DLT pipeline. And you can also click on dry run. So what will happen in dry run? It will create the DAG for you and will show you, hey, this will be the code that will be running if you will run your code. So it will not actually run your pipelines, it will create the DAG, basically lineage for your pipeline, and it will show you this is the result that you can expect. Okay, make sense? So this is the DLT pipeline, and DLT is like amazing, amazing, amazing. Just go and master that video, because you will master delta live tables. Trust me, after watching that video. Trust me, it is very, very important and it is very nice. Okay, so let's wait for this particular scenario to be completed. By the way, we have one error in the midnight. Let's see. df cust is not defined. Okay, where is that df cust? Where is that df cust? Oh, who wrote here df cust? And by the way, we didn't even define that particular thing. We need to say spark dot read dot table, and then we need to say PySpark kata dot source dot customers. Perfect. Let me say dry run for one more time. Just a typo. Oh, we need to just say return df. Yeah, we know that. Return df. Perfect. Perfect. Cannot access local variable df where it is not associated with a value. Dataset is defined in the pipeline but could not be resolved. Where is that error? Okay. Oh, makes sense. By the way, I just trusted AI and I just used its code, but I should have just written my own code. So basically, it just skipped the data reading part. So here I can simply say spark.read.format, not format, basically table. And we can simply say customers enriched, that's it, basically raw. You will ask, hey Ansh don't we need to put catalog name and schema name? No, because this particular table is associated with this particular catalog and table. And do you know what is the catalog and table for this particular DLT pipeline? Let me just show you. Go to settings, and this is the default catalog. You can actually change it. If I say catalog name should be PySpark kata and schema name, let's say, should be source. You can even create a new schema, let's say DLT schema. Okay, you can simply say save, and now it will automatically fill these values for me. Okay, very good. Now, by the way, oh, we have YAML as well. Very good. So we have UI, JSON. JSON is not like widely used for these things. YAML is the file that is used for configurations and all, for your dabs, for your Docker, everything. YAML is very important. So let's say dry run. Do you know the full form of YAML? Do you know? Let me just show you. You will say, hey, what is this full form? It is saying ain't markup language. What is this? So ain't markup language, or you can say basically it is a human readable data serialization language commonly used for configuration files and data exchange between applications. Basically, in short, whenever you just want to create configuration files or basically config files, YAML is the most adapted format because it is easy to read, it is easy to, you can say, maintain, and easy to update as well. Very easy. Some people also call it as like another markup language. Okay, or some people say it as yet another markup language. Some people say ain't markup language. So it is very funny, but yeah. Okay, let's see our DAG. On the cluster, ensure the Unity catalog configuration is on. Okay, permission denied, could not move tables across catalogs. Wow, what is this error, man? Encountered an error with Unity catalog while setting up the pipeline or cluster. The Unity catalog configuration is correct and that required catalog schema exist are accessible. Also verify the cluster has appropriate permission to access. I think there's a typo in catalog name. I think so. PySpark kata.source.customers. Okay, that is fine. Okay, and it is saying customers raw. Okay, where is the error? Customers raw. We have a bug, so I was just trying to figure it out, like what is the issue, and I think it is due to some backend cluster permissions. So what I will simply recommend to just copy all the code. Okay, and then just go to the jobs and pipelines and then just create a new one quickly. and then you can simply name it, let's say DLT new. Okay, and then you can pick, and I don't like spaces, so I'll simply say, and then you can pick PySpark Keta, and schema will be, let's say, DLT schema, because you already created that, and simply go to SQL because there was like nothing wrong in that code. Everything was fine. I don't know, like there was some cluster issue and all, and I don't rely on these free resources for Databricks, so it is what it is. So let's do the same stuff. Nothing changed. Let me just move all these two files to the trash, and let's create our new file, which will be, let's say, mm, same file, let's say first.py. Okay, and then we can simply paste our code, same code, and everything should be fine. I will just make one change quickly. So I was just simply testing something, so I will simply rename it to customer raw. Okay, customer raw, customers raw. Okay, and one change I can make, instead of just reading it as a batch table, let's read it for like as a streaming table, just for fun. Okay, and then let's say try run. Let's see what happens here. Let's see. So this is DLT new. Okay, okay, makes sense. And we can even move this folder to our main folder, which is PySpark real-time scenarios, or basically scenarios. But first of all, let's test it out. Okay, if it is working fine, because I don't know like what was wrong there. Maybe some cluster issue and all with that pipeline. Spark object has no attribute read stream table. This is, I think, doable. So what is the issue? Spark session object has no attribute read stream table. Oh, read stream. Oh, I see. So this is read stream dot table is not allowed. Okay. Then you can simply say there's a typo. See, we didn't add dot here. So then I can simply say try run. Let's see. This is like this is doable because we know the error. We know like there's a syntax error, but oh, that actually ran fine. Perfect. So I can also click on this button, which will show me the graph of this particular pipeline. So this is the graph. I can also maximize the screen. So this is the maximize button. There was a like button to maximize it to the whole screen. I think, yeah, maximize. So as you can see that this is the graph that we have. This is a streaming table which is for raw layer, streaming table for the transform layer, and then streaming table for the, you can say, dimension type 2. So this will automatically create the slowly changing dimension type 2. If you just want to run this particular ETL pipeline, you can now click on run pipeline instead of dry run. But obviously I don't want to waste the resources. You can simply click on dry run and it should run fine, because if you click on dry run, that means everything is fine. Okay, makes sense. So I hope you enjoyed this PySpark real-time scenarios video, and if you did, just drop a lovely comment on this channel, and just keep supporting, keep loving, and just click on the video that is coming on the screen right now, and happy learning. I'll see you there.